Доброе утро, коллеги. Uh, Good morning, everyone. Welcome back. Uh, Welcome back. I believe the first talk has been uh, cancelled because of the sickness of the presenter. So we will give it probably a few minutes. I would say three, 4 more minutes to have more people come back to the conference. Thank you very much for being with us this morning. And then if the presenters of the second talk are with us, then we'll start at 5 past with that presentation. Meanwhile, yeah, I'd say we give it we'll give it a few more minutes for people to come back.
Good morning, ladies and gentlemen. Welcome back. We are starting our second conference day, and as Professor Starov has already announced, we are skipping the first slide presentation due to the physical illness of the presenting author. So we are starting from the second presentation, which is titled, Can we identify a word by its upper half? ERP correlates of letter degradation during word recognition. And the presenting author is Marta Vergara Martinez, and she is from University of Valencia, and her co-authors are from University of Minho and Nebrija University. Marta, are you here with us?
I'm here. Can you hear me?
Yes, we can. Hello, good morning.
Good morning to everybody. I hope the other presenter is fine. I'm sorry. But okay, shall I share my screen?
Not yet. Have you started screen sharing?
Yes, now it's okay. Can
you
you see?
It starts working. Everything is perfect.
Okay, thank you. So shall I start then? No. So
yes,
good morning. Okay, thanks. Good morning, everybody, and thanks for attending this talk. So, sorry. Yes. So as you can see in this example, you might not realize at first, but it is easier for readers to identify the original word metro when presented with the upper half of the word compared to the lower part of the word. The reason behind may be that in the Roman alphabet, the information at the level of letter features seems more distinctive in the upper part of letters than in the lower part. Sorry, so see, for example, here that the ambiguity is larger for the lower part of the letters compared to the upper parts. However, the upper part advantage is obtained for words and not for isolated letter identification, as was found by Blaise and colleagues in 2009. Therefore, it is mainly related to the dynamics of the visual word recognition process. A few years ago, Perea and colleagues in 2012, excuse me, used the masked repetition priming technique to try to address the locus of this advantage. Note that in the masked priming technique, the prime is presented for less than 50 milliseconds, but it does affect the processing of the target while the participant is not aware of it. And this is a very safe way to measure bottom-up processing while avoiding strategic decisions from the participant. So Perea and colleagues found that the latencies for word targets like metro, a word like metro, were faster when preceded by either the upper part or the prime itself, compared to targets being preceded by their lower part. And what this shows is that the cognitive system is able to compensate for the missing information in the earlier stages of word processing. Or in other words, the upper part of words activate to a large extent their corresponding lexical units during the earlier stages of word processing, in the absence of top-down conscious strategies. But note that, that the masked priming experiments measure recognition latencies of the same intact target preceded by a prime, here either the upper or the lower part. So we wonder, what about normal reading? What about isolated word identification? Does the cognitive system compensate perceptual degradation to select a lexical match? Note that there is fMRI evidence on the increase of posterior parietal regions, on the increased activation of posterior parietal regions when reading words in a non-standard format. And this activity has been interpreted as a switch from an automatic word identification strategy to an attentional-based reading strategy. So here we tracked the electrophysiological signature of the upper part advantage in words of different frequency. And this allowed us to assess the time course of the perceptual manipulation, upper versus full, and the time course of a lexical manipulation, such as word frequency. So the perceptual manipulation would impact the early stages of visual automatic processing, which are associated with the N170 component. In contrast, the word frequency manipulation was expected to impact later lexical semantic stages of processing, such as the P300. And this scenario would be consistent with a cascaded model of processing where a non-standard type of stimuli is rapidly normalized according to orthographic knowledge previous to lexical access. But another possibility was to obtain, an interaction between the perceptual and the lexical factors in the early stages of processing. Note that the experiments from Perea and colleagues showed that there was an early effect of, that the upper part advantage tapped early stages of processing. So we might expect that there could be an interaction between the perceptual and lexical factors in the early stages of processing. This would mean that the cognitive system compensates the visual ambiguity of the upper part of words with top-down lexical feedback via the attentional parietal pathway activation. So this second scenario would be more consistent with a fully interactive system that brings top-down feedback when perceptual ambiguity exceeds the capacity of the early detectors during visual word recognition. So this is the, I'm going to describe a little bit the experiment. It was a lexical decision ERP experiment where we included these two manipulations, the intact versus the degraded stimuli, which was the upper part of words and non-words, and word frequency, high versus low frequency words. We have to say that we only included stimuli with unambiguous letters in the upper portion. So letters like I or J were not included. Okay, just some details about the experiment. There were 200 words and 200 pseudo words, and half of the words were of low frequency and the of low frequency and high frequency. So we have 50 items per condition. The frequency of letters was equal across high and low frequency words, and it was a lexical decision task, so participants were expected to answer yes or no to the stimuli. If it was a real word in Spanish, they have to say yes. If it was not, they have to say no. So for the results, for the behavioral results, there was a main effect of each of the factors that were included: frequency and degradation. So lower RTs for the fastest latencies for the high frequency words compared to low frequency words, and fastest latencies for the full compared to the upper part of words. There was no interaction between these two factors. For the ERP results, we have the perceptual comparisons here, and you can see the shape of the waves for both the full and degraded condition, and it was very, very clear that the difference was started very early in the N170. And for the lexical frequency comparison, the effect started later, in a later time window. Importantly, there was no interaction according to the, in the amplitude of these components, but there was an interaction in the latency of the emergence of the frequency effect, because it started a little bit earlier for the degraded condition compared to the full condition. So as a summary, the behavioral results showed a degradation effect, a main effect of degradation, a main effect of word frequency, which point to an additive pattern. And for the ERPs, there was a main effect of degradation and a main effect of word frequency. They didn't interact, and they occurred mainly in different in different stages of word processing. So the conclusions, okay, so first, both behavioral and ERP results converged as they showed independent additive effects of perceptual and lexical manipulations. While there was an early effect of degradation in the M170, no early impact of word frequency was obtained in this stage. So lexical information does not percolate into the earliest stages of processing. So our data favors the first scenario. The upper part of words are rapidly normalized in terms of orthographic knowledge. So the cause is observed in the early stages of processing, as shown by the early ERP effects, and also in the RT measures. And the earlier effects of word frequency in the degraded words than in the intact words may reflect the impact of attentional resources in the course of lexical decision, but not in the early encoded stages of processing. So that was all. I hope I make it as clear as possible, although I was speaking too fast. So if you have any question. Hello?
Thank you very much.
Okay.
Everything was clear. Yes, we have actually quite a time for questions, since, yes, in the absence of one presentation, we can maybe loosen up a bit all the time limitations for this session. So we can allow a bit of discussion. Yes, Yuri Shterov has a question. Please go ahead.
Yes, thank you very much for the presentation. I have a more general question. Is there what makes the upper half, I'm sorry if I missed it, what makes the upper half more salient? Is this attention, or is there something about letter shapes? Has anyone studied this, whether more like parts of letters that are in the upper half are more informative, more distinct?
Yes, originally in the behavioral experiments, it is true that individual letters are more informative in the sense that there is less ambiguity for the perceptual detectors. Can I show you see here, for example?
Yeah, I'm sorry if you said this and I missed it, but
okay, I was talking too fast. But you can see here that the ambiguity increases for many words. Oh, I mean, sorry, and the ambiguity is larger for the lower part of the letters. You see that
so the upper parts are more unique in that sense, and they allow for easy identification. Do you know if it has anything to do with attention, that people tend to pay more attention to the upper halves, or is this a universal? Is this something universal for all the alphabets?
Yeah, that's I mean, it's a great question, because it's something that it's not only maybe at the perceptual level, but also at the way that the alphabets were designed, or the way they developed. Precisely. I don't know if it's occurring generally for all alphabets, that there are specific parts which are more informative are in the upper part, and it's like showing that we are paying attention always to the upper part, because it's normally more informative to the upper part of objects. It's something that we for sure had to have to analyze, because maybe this is just an example of perceptual, I don't know, design. But it's I mean, for here, I'm not sure what happens in the other alphabets, and we for sure have not compared this with the upper part of objects, but it would be a great step to see if this is something more general. Yeah.
Right, thank you.
But I also have an idea which might sound a bit like a too distant association, but still, also about these potential more general mechanisms of visual recognition and reading in general. I just thought of that. You probably know, this F-reading eye movement pattern, which was described for reading web pages, which tells us that usually people scan through the page, so they sort of just read like top down on the left side, just skimming through the text, and then probably they just read maybe a top 2 or top 3 lines, then skip through another a very substantial part, like a whole paragraph, and then read maybe something in the middle of the page. So it's also tends to gravitate towards the upper part. And this is, of course, completely different scale, because these results are for the whole page, the entire page. But what if this is just something more basic, that we are dealing with the upper parts of any text or any letters, or is this too general, such a like overgeneralization? What would you say?
Yeah, so you mean like, for example, that after reading many texts and after making an effort to capture the most important information, going fast, maybe we are trained to extract information from the upper part, and maybe that's what we are getting in this experiment. But yeah, that's a possibility. I'm really not sure right now if it can be disentangled in an easier way. Maybe it could be interesting to see what happens if you train participants to grasp information from the lower part, and maybe the results are similar. But I'm not sure. But I think it's a combination of everything, that the letters themselves are informative, that we have managed to learn this, to optimize this information, and afterwards we can use it when we are reading isolated words. But yeah, I mean, I think I like the proposal that you have information in the upper part of objects, which are very informative, and maybe the alphabet has managed to optimize that tendency in, I don't know, for whatever reason, for cultural or biological reasons. Are we just exploding the two things, the training and the natural or the biological aspects from our vision? I'm not sure, but those are like very big questions.
Indeed. Thank you very much. And there is another commentary from Richard Chilcock in our chat. I'll just read it. Okay. I wonder if there is any role for dorsal versus ventral visual pathways. Goldstein and Babkov, 2001. I know the stimuli are small, but the upper lower cutoff in the retina is not sharp, but it might be worth looking at.
Can you read it again, because I'm not looking, I cannot see the chat.
It's in the chat.
It's in the chat. Yes, definitely. I will read it again. So I wonder if there is any role for dorsal versus ventral visual pathways. And there is a link to the work of Goldstein and Babkov, 2001. I know the stimuli are small and the upper lower cutoff in the retina is not sharp, but it might be worth looking at.
Okay, yeah, no, I understand. Yeah, that's a great proposal. I know from this differentiation between the ventral and the dorsal, so maybe that's a good way to think about these results in those terms. Yeah.
Okay, thank you very much. Any more questions? Looks like no more. So thank you very much, Marta, for this very thought-provoking presentation. And we hope this line of research continues, and
yes,
you can present more results next time. And now we proceed to the next presentation. And this one comes from our lab, Laboratory of Behavioral Neurodynamics. And the presenting author is Daria Gnedych, and the topic is differential effects of TDCS of Wernicke's area and its right hemisphere homologue on contextual acquisition of novel words.
Can you see my screen?
Yes, it works, but you could probably click on full screen mode. But yes, everything works perfectly. Thank you.
Hello, everyone. My name is Daria. Yes, I'm presenting the Laboratory of Behavioral Neurodynamics, and I would like to tell you about the results of our current project. We are interested in the neural mechanisms of abstract and concrete semantic acquisition, which could explain the behavioral differences in processing between these two domains. We agree with the opinion that concrete concepts are those that have references with the real objects or physical worlds and can be detected with 5 senses. For example, cat, pen, ice cream. We can see it, we can touch it, we can taste it. On the contrary, abstract concepts cannot be felt with our senses and are more about non-physical entities, situations, complex mental states, relations between objects, and so on.
Daria, I'm sorry for interrupting, but there are some comments that the sound is not very clear. Could I ask you to speak maybe just a bit louder so everyone can hear properly?
Yes, of course.
Maybe closer to the microphone.
Behavioral studies show that concrete words are better remembered, faster read, comprehended, and learned in comparison with abstract ones during different cognitive tasks. Is it okay now? Can you hear me?
I think it's a bit better. Yes, still a bit sort of blurred sound, but I think it can be recognized. Maybe other participants can comment whether it's heard.
Yes, it's become better, but not clear, but it's understandable.
Okay. This means that if we compare processing of the words cat and knowledge, cat will get certain advantage over knowledge. This advantage of concrete over abstract semantics is known as concreteness effect. To reveal the reason of these distinctions, neuroimaging studies were carried out. It was found that the processing of concrete and abstract words involves different brain areas. Concrete word representations are more distributed and involve different modality-specific areas. The abstract semantics relies more on the core language areas of the left hemisphere, which are known as Broca's and Wernicke's areas. Moreover, the role of the right hemisphere in processing of various types of words and semantics is also emphasized. However, brain activation patterns as such do not necessarily indicate that a particular area is needed for coding certain information. Neurostimulation techniques allow to assess causally the involvement of particular brain area regions in specific cognitive functions. The DCS is a non-invasive method of transcranial brain stimulation in which direct current of a very low intensity is used. From the studies of the motor system, we know that anodal TDCS is mostly often associated with facilitating, whereas cathodal TDCS with inhibition of excitability. Some of the investigations dedicated to cognitive functions proved this inhibition effect of cathodal stimulation, but others showed performance improvement after cathodal TDCS, suggesting that cathodal inhibition, common for motor studies, cannot be simply assumed to apply to the language function in the same way. Taking into account the role of right hemisphere in language processing, we are interested how anodal and cathodal TDCS of Wernicke's area and its right homologue can influence the process of novel concrete and abstract semantics acquisition. The sample included 5 groups who received anodal, cathodal, or sham TDCS of Wernicke's area or anodal and cathodal TDCS of its right hemispheric homologue before learning. At the slide, you can see the example of Ellitrope's location for the left hemisphere. The same location symmetrically was for the right one. The procedure of word form creation consisted of choosing 20 nouns from the Russian national corpus, which were divided into 2 equal groups and balanced for their length, phonological structure, lemmas, and ultimate syllables frequency. Then the last syllables of the words were replaced in the manner you can see on the screen, and the novel word appeared. Semantics of concrete words was developed using rare, obsolete, or ancient objects, which were unfamiliar to the participants. Novel abstract words were adopted from foreign cultures with the requirement that no words for these concepts existing in Russian language. In total, 10 novel concrete and 10 novel abstract concepts were created to be paired with new word forms in a contextual learning setting. Acquisition of novel concepts was achieved by reading context sentences describing situations through which participants could understand their meanings. This allowed us to mimic natural acquisition of new words in real life. At the slide, you can see an example of context sentences. They include information about main features of these objects, how and where we can use it. You can read them and try to guess what its circle now is. So here, this is a firefighting robot which is used in search and rescue operations. Each concept was described through sets of 5 sentences, which were equalized for length and presented visually word by word. Each set of the sentences was presented in randomized order. The contextual acquisition of novel words was after the TDCS application. The learning outcomes assessment procedure was held during 2 days of experiment, immediately after the learning session and after an overnight sleep to reveal any consideration effects. The assessment consisted of 3 lexical tasks: free recall, recognition, and lexical decision, and 2 semantic tasks, including free-form definition and multiple-choice semantic judgment tasks. Thus, suggested research design allowed us to compare directly novel, concrete, and abstract words learning outcomes after TDCS of different polarities and hemispheres. The results of the study are the following. Red lines on the bar chart denote differences between stimulation group. Black lines denote differences between days. Black lines denote differences at tendency level, and solid lines denote significant differences. So the between group comparison revealed the positive effect of cathodal stimulation of Wernicke's area on abstract semantics consolidation, which was demonstrated in higher accuracy of free form definition task on the second day. On the first day of assessment, the participants from the another TDCS of right hemisphere homolog group were more successful in accuracy of abstract words in comparison with those who received cathodal TDCS of the same area. The definition accuracy performance was observed in the sham group and after the nodal stimulation of both hemispheres for abstract words. However, this decrease didn't take place in the groups which received the cathodal stimulation. Looking at the next chart, you may think that only one difference was found, but this line indicates only between group difference, although differences between days were also revealed in all groups for both semantic types, except abstract words in the cathodal group of Wernicke's area. This is marked with the text in the box. It means that the quality of definitions on the second day was significantly worse than on the first day. We decided not to highlight all these differences to avoid a mess of lines on the bar chart. So what you can see here is that on the first day, definition quality of abstract words was better after the another TDCS of right Wernicke's area in comparison with its cathodal stimulation. Comparisons between hemispheres showed that cathodal TDCS of Wernicke's area was more effective than cathodal stimulation of its homolog for abstract words on the second day in the multiple-choice semantic judgment task. Also, it was revealed that participants in another TDCS of Wernicke's area group made more mistakes for concrete words on the second day in comparison with the first one. It is remarkable that in the lexical tasks, no between-group differences were revealed. Only between the analysis showed the decrease of recognition, lexical decision, and free recall tasks outcomes. Especially the decrease of task performance on the second day was found for concrete words in another TDCS of Wernicke's area group in recognition task, for abstract words in lexical decision task, and for concrete words in free recall task in cathodal TDCS of Wernicke's area group. Thus, it was revealed that both stimulation polarities and loci differentially affected context acquisition of novel concrete and abstract words on lexical and semantical levels, which appears more clearly for abstract words. One of the most interesting results is an enhancement of acquisition processes after cathodal TDCS of Wernicke's area, whereas the opposite effect appears after the same polarity stimulation of its right hemisphere homolog. This can be explained by the different involvement of 2 hemispheres in semantic representations, as well as indirect influence of TDCS on contralateral areas of cortex through cross-callosal relationships. Thank you for your attention.
Thank you very much, Daria. Very rich data. We have a question already from Anastasia Lopukhina. Please go ahead, Anastasia.
Hello, thank you very much. It was a very nice talk. I have a question about the sentences in which target words were embedded. I'm curious, why did you decide to give sentences and not a full text, a text with these target words, for example. And could you please give more detail about how you selected these sentences, whether you tested that the meaning of the target word is indeed can be acquired from these sentences? So could you possibly give more detail about the sentences? Thank you.
Yes, thank you for the question. Yes, we tested these sentences. We had the sample, which read the sentences and tried to guess what the meaning of this word, this new word, is. And they said that it is okay. This sentence they could be understand. And the meaning of the word in this sentence could be revealed while you are reading them. What about the text? Well, this is a very interesting question because when we thought about the stimulus material, well, maybe we didn't think about the text because it is more complicated to show it in the screen, and we need the demonstration word by word of these sentences. So if it is the text, it will be not so easy to show it word by word, and it's not easy to read it this way.
Okay, thank you, I see. Thank you.
Mm-hmm.
Thank you. Any more questions? I would ask one myself. Daria, could you please explain a bit more what is the difference in results of stimulation of Wernicke's area between abstract and concrete words? Because from what I understood, they are equally enhanced, or maybe I got it wrong.
Mm-hmm.
It wasn't one of the results slides.
Mm-hmm. So we can see that the stimulation of Wernicke's area works equally because we see that cathodal TDCS has a facilitation effect on acquisition, and it is more for abstract words. But the anodal TDCS shows the effect not for abstract words, but for concrete words. So we see the difference between the acquisition of these two types of semantics when we have these different types of stimulations.
Okay, thank you. I just probably focused on these second and third lines, abstract words in cathodal, TDCS of Wernicke's area, and okay, yeah, I see. Thank you so much. And I see now that we have a commentary from Richard Chilcock in our chat. Great data. Do you think the left and right hemispheres are behaving inhibitorily between the homologous areas?
Mm-hmm. Well, that's an interesting question. Thank you. Maybe I'm not ready to answer this question right now. I mean, to give the clear answer of this question, I think this is about more for discussion. But sorry, maybe I'm not ready to answer this question.
Well, Richard adds that he would be happy to chat offline.
Okay. Okay.
Who knows when this offline opportunity will open up for us, but definitely I think you can exchange emails and maybe just continue chatting in the private mode in the same chat as well after the presentation. So thank you. Any more questions? Okay, no more. Thank you very much, Daria, for a very clear and very rich presentation. And we are going further. Now we have a presentation by Sofia Goldina and her colleagues from National Research University Higher School of Economics. And the topic is eye movements during reading in Russian-speaking children with dyslexia.
Yes, hello.
Hello.
Can you hear? Can you see?
We can see you. I think the presentation is opening. It's just a blank screen. My Zoom tells me that I'm viewing your screen, but there is actually nothing in there.
Ah, there we go. Let me try again. How about now?
Yes, now everything works perfectly.
Okay,
so
great.
Please.
Hello. So today I'm going to be telling you about our research that focuses on eye movements during reading in Russian-speaking children with dyslexia. First of all, let's take a look at the definition. Dyslexia is a neurodevelopmental reading disability that impedes reading fluency and text comprehension despite normal intellectual capacity, as well as normal hearing and normal eyesight. So those factors do not contribute to the fact that people with dyslexia are unable to learn how to read. And it affects around 10% of the population. There's a bunch of theories on what dyslexia actually is, but some of the most prominent ones are the magnocellular theory, which suggests that the main cause of poor reading performance in people with dyslexia comes from a visual deficit. And there's also the phonological theory that, on the other hand, names a linguistic deficit as the main cause of the poor reading performance, specifically disrupted phonological processing and impaired processing of speech rhythms. We know that reading and phonological processing are two very interconnected processes, and it has been shown that in children at the pre-reading stage, those of them who have higher skills of phonological processing later on become more efficient readers. This also works the other way around. The more reading experience children get, the better their phonological processing skills become. Now let's take a look at an overview of the previous findings in the research of eye movement patterns in children with dyslexia. We know that children with dyslexia have longer fixation durations while reading, which means that the stops that their eye makes at the word during which information is being processed takes more time. They have also a larger number of fixations. The saccade lengths are shorter, so the short eye movements in between fixations are shorter in children with dyslexia. They make more aggressive movements. The eye goes back a lot more. And there's also less skipping of short words. Skipping of short words is considered a typical characteristic of efficient readers. The eye does not make any fixations on short words. It has been found by some researchers that eye movement difference can be associated with linguistic processing. And in our research, we operate under that assumption as well. Our research questions were as follows. First of all, we wanted to know how phonological skills influence eye movements during reading in children with phonological dyslexia compared to controls. And second of all, we wanted to investigate if linguistic properties besides length and frequency influenced eye movements during reading in children with dyslexia. Our participants were all primary school students from grades 1 to 4, and the sample included 29 children with diagnosed phonological dyslexia, as well as 47 controls. We assessed reading fluency using the standardized assessment of reading skills in Russian, and all 47 children from the control group had normal reading according to this test, while 25 of the 29 participants with dyslexia had dyslexia according to this assessment. And all children had normal hearing and normal nonverbal intelligence. For the reading portion of the experiment, we used the child version of the Russian sentence corpus that includes 30 sentences that are 6 to 9 words long. You can see some examples with translations on the screen below. The isolated sentences were placed in the middle of the screen, and children were asked to read them silently. So the procedure went like this. The participant fixated on the black circle, then it changed to a sentence, and the child read the sentence silently, and then fixated on the red circle, which then the sentence changed to either the next sentence, or after 10 sentences, there were comprehension questions with 2 options of answer. Oops, sorry. For the phonological assessment, we used the Russian test of phonological processing, which was developed in order to assess children's phonological processing skills and their interconnection with reading. The test battery included 7 subtests. Here they are listed from least difficult to most difficult. So the subtests were phoneme discrimination, lexical decision, pseudo-word repetition, phoneme detection, phoneme isolation, calculating the number of sounds in a word, and the last most complex subtest, changing the sound in a pseudo-word. It was the hardest one because it required the most skills to be used simultaneously. You can see an example on the screen. In our analyses, we chose the following dependent variables. We looked at first fixation duration, gaze duration, second run dwell time, total reading times, and probability of skipping a word. For our predictors, they can be divided into 2 groups. First of all, the characteristics of the participants, so group, grade, and mean accuracy in each of the subtests of the root top, and also the characteristics of the words that the participants read, so word length, word frequency, number of morphemes, word class, morphosyntactic ambiguity, and whether the word was in its base or non-base form. Let's take a look at our results. Overall, children with dyslexia read slower than typically developing children. However, they turned out to be more likely to skip a word. As for the interaction between group and the characteristics of the participants, first of all, children from higher grades read faster. However, this effect was less prominent in children with dyslexia. And children from higher grades were also more likely to skip a word. Less likely to skip a word, and this effect was even more prominent in children with dyslexia. For the root top, we found that better performance in 2 of the root top subtests, phoneme isolation and changing the sound in a pseudo word, was associated with faster reading times, and this effect was more prominent in children with dyslexia for only the last subtest, the most complex one, changing the sound in a pseudo word. For the interaction between group and word properties, we found interaction only for those 2 following variables, word length and word class. All children read longer words slower, but this effect was even more prominent in children with dyslexia. And longer words were more likely to be skipped, actually, by children with dyslexia compared to controls. As for word class, verbs were read faster than nouns, and this difference was more prominent in children with dyslexia. Pronouns were read slower than nouns, and this difference was less prominent in children with dyslexia, which was also true for function words. The effects that applied to all children were the effects of frequency, of morphosyntactic ambiguity, and for the number of morphemes and the base non-base form of the word, we found no effect for both groups. So what conclusions can be made from those results? First of all, we can suggest that the fact that we found that the difficulties with the most complex phonological task in RUTOP were associated with longer fixations in children with dyslexia compared to controls. This allows us to suggest that perhaps what prevents Russian-speaking children with dyslexia from reading effectively is not impaired elementary phonological processing, but rather impaired complex phonological processing. So for the linguistic characteristics, the fact that children with dyslexia had a bigger effect of word length is maybe a marker of the fact that children with dyslexia read according to the sublexical strategy, which this is a common effect found in languages with more shallow orthographies than English. And the effects of word class that we found need further investigation because they are different from what was found in adults, Russian-speaking adults. So yeah, and the other linguistic properties that we chose did not strongly distinguish between the two groups. Finally, I would like to address a peculiar finding, the fact that children with dyslexia tended to skip words more than controls. This can be explained by the fact that some of the younger participants in our dyslexia group tended to read using the reading avoidance strategy. So this means that they, because of their young age, because of their extreme difficulties with reading, they tended to just not fixate on the words, skip them all entirely without comprehending the sentence. So this led to higher skipping rates. And these results show that for children with dyslexia, higher skipping rates are actually, on the contrary, like a bad characteristic. And older children with age, with more practice, they are become less likely to skip words. And this means for them that they spend more time and effort on reading, which is a very positive characteristic. That's all. Thank you so much for your attention. Would you like to ask any questions?
Thank you very much. Brilliant presentation. Any questions, please? Okay, I have one. It's actually maybe more like a commentary and not even a question, and it will bring us a bit beyond your empirical results, but I'm interested in this very, very last part that you mentioned, that dyslexic children, they tend to just skip the words they cannot read and just ignore them. From the research on intelligence and on more various aspects of that, rather than just verbal abilities, it is very well known that this is one of the very, very immature intellectual strategies in general. And it's not just in children. We can observe it in adolescents, in adults, and in a very efficient adults as well. Like if there is something I personally do not like, or I'm afraid of, I'm just pretending, oh, there is nothing in there, and I just exclude it from my perceptual field. So is this specific, you personally, what you believe, is this specific to just dyslexia and verbal things, or is this more general mechanism, which is, of course, quite an inefficient one? And this brings us to the very fundamental question of what is dyslexia itself, because from what I heard, there are other theories believing that dyslexia has nothing to do with intelligence, that intelligence is definitely non-impaired. And we can probably say that there are executive functions that are not very well working and some other higher tier cognitive abilities. So how could you comment on that, please? And we have another question and another commentary.
Well, thank you so much for your great comment. I think that definitely this is this strategy goes, I think, maybe beyond people with dyslexia. I think this is something that can be commonly said, like we tend to not try to understand if we don't understand something, or try and complete something if we don't understand, but rather just avoid and not do it entirely, of course. Yeah, I think that this can also, this is not a, maybe not a dyslexia specific thing. I think this may even like occur among younger readers without dyslexia as well. Yeah, but definitely you were also right about the fact that intelligence, has nothing, impaired intelligence has nothing to do with dyslexia. So this is, characteristic of dyslexia, that intelligence is not impaired. Yeah, but thank you so much for your comment.
Could I possibly add
that would be
something
great to discuss it maybe later. And I see the commentary in chat from Manuel Perea, and then there is a hand raised by Ekaterina Stankova. So let's go step by step. Manuel Perea says, I was wondering how the kids with dyslexia process pseudo words in which the modified letter has a different sound in the Latin script. It is in chat, so you can read it there. I was wondering how the kids with dyslexia process pseudo words in which the modified letter has a different sound in the Latin script.
A different sound in the Latin script. So, do you mean letters that look in Cyrillic, letters that look the same as Latin letters? They're just the sound is different. Actually, thank you so much for. Right. Yeah. Okay, I understand this one. We haven't really looked into this. To be completely honest with you, I think that maybe some of our younger participants, for sure, they might not even know that such a thing exists, because younger children maybe only even just started learning English, or have not yet started learning English, children with dyslexia especially. So thank you so much for that interesting comment. I do not think this influenced anyhow the process, but yeah.
Thank you. And we have a question from Ekaterina Stankova.
Hello, I have a question about word skipping in dyslexics. Don't you think that it maybe means that anticipation processes are more developed in dyslexics than in normal children, typical developing children?
I'm sorry, I think I turned off the screen share. Could you repeat, please?
Don't you think that that fact that dyslexic skip some words could mean that anticipation processes are more developed in dyslexics? They skip word and they just trying to figure out what it was.
Figure out. I'm not sure.
They just wonder what was in this. They don't read. They just wonder.
I can tell you for sure that the comprehension in children with dyslexia, the answers to the comprehension questions, the rates, the accuracy rates were definitely lower than controls by quite a lot, I think. So this definitely means that, children with dyslexia that have those super high skipping rates, they do not necessarily, they do not try to comprehend what they read. When they were answering the comprehension questions, if they were, I think they may have been just guessing most of the time, I believe. Because, and this also, this is shown that the comprehension rates are much lower.
Thank you very much. I'm afraid I need to say this was the last question for this presentation, but not the last in general, because we can continue online. Just in chat or somewhere else. And we need to proceed to the last presentation in this section. And this is by Nina Zdorova. As far as I understand, there are some technical issues, so we have the presentation, and this one will be run and shared by one of our team members.
Well, strictly, basically, it's not needed. I think I'm able to share my presentation as well. Yes.
Great.
Let me try. Yes, let me try. I hope it works. And you will see right now.
From National Research University Higher School of Economics, and her colleagues are from the same institution and also from Sirius University of Science and Technology. And yes, looks like everything works. The title is Logical and Orthographic Processing after reading effect, reading fluency in Russian children. Sorry.
Exactly. Yes. Thank you very much. Thank you very much for this great welcoming. So let me start with my presentation. Thank you very much for mentioning my authors as well and for mentioning our institutions. Indeed, this research was conducted by a whole research group in collaboration with different institutions, right? So talking about reading, I would like to emphasize that reading is a complex cognitive skill that implies and involves both processing of visual information as well as processing of linguistic information. And regarding linguistic information, different researchers tend to believe that the main linguistic processing is presented by phonological processing and orthographic processing, whereas there is a huge debate what type of those processing, what type of processing types, let's say, contributes the most, depending on different factors, depending on languages and age of children, etc. So our research question was interests us the most is how do phonological and orthographic processing skills, as well as age of children, influence reading fluency in Russian-speaking children. It should be also underlined that all the studies mentioned here on the slide, they were predominantly conducted on European languages, and this question on Russian language is rather understudied. However, there is still a great research conducted by our colleagues, Rakhlin and her colleagues as well in 2019. It's a really impressive study where you might see on the slide this impressive number of participants, children aged between 7 and 14 years old, and the number of participants is 1,344. Our colleagues indeed investigated the same question: what type of processing influences reading in Russian? It means in Cyrillic script, right? And the main findings were that phonological processing in Russian does not contribute directly to reading in Russian, right? Whether orthographic processing is indeed of primary importance for reading fluency in Russian-speaking children. We want to point out that the study conducted by our colleagues and our study has a major methodological difference, which is the method of measuring phonological processing. In the study of our colleagues, they have used a task, a pseudo-word repetition, whereas like 1 year later, in a study conducted by our colleague as well, in Dorofeeva and her colleagues in 2020, it was emphasized that complex phonological tasks, they predict reading much better, and they predict reading rather than simpler tasks like pseudo-word repetition. So going to our methodology, we have collected data from 117 Russian monolingual children. All of them were school-aged, and they were aged from 6 years old till 12 years old. The mean age was 9, and standard deviation is 1.6. None of the children were diagnosed with any speech pathologies, and their nonverbal intelligence was also measured and was controlled by the test of Raven matrices. And after this test on Raven matrices, all of the children performed 3 behavioral tests that are of our primary interest, right? The first test was aimed at measuring reading fluency, as we considered as a number of correctly read words per minute, right? This test was developed by Kornev in 1997 and is considered a standardized assessment tool for measuring reading fluency in Russian. And the procedure was as follows: just children were given a text printed on a piece of paper, and they had to read this text at least for 1 minute, right? The second test was changing a sound in a pseudo word. And as I've already mentioned, this assessment tool was developed by Dorofeeva and her colleagues in 2019. This test contained 24 stimuli in total, and we measured accuracy in those tests. So the procedure looked as follows. There is an instruction in a tablet. All the children were performing this task on a tablet. For example, change the sound V to the sound V. Mi, mi, va. So a stimulus was mi, mi, va, a pseudo word which does not exist in Russian. And the sound opposition measured here was non-palatalized V and palatalized V. And the expected response, and the correct one would be mi, mi, va. And finally, the test rapid automatized naming was implemented in order to measure orthographic processing. This test was developed by Denkler and Trudel in 1974, and it looks, as you might see on the screen, it is a 50-digit matrix of figures 2, 4, 6, 7, and 9. And what we measured was time spent on this task completion, on naming the words, figures from left to right and from up to bottom. So the results we received, all the data that we collected was analyzed in R by means of linear regression, and you see the packages implemented for this analysis. Our dependent variable was reading speed. I again remind you, it was number of words read per minute, but only correctly read words, right? And the factors that we analyzed were age, phonological processing level, and orthographic processing level. So our results, as you might see on the slide, we see that the first finding is that indeed reading speed, or what we also call here reading fluency, depends on age. The older a child is, the faster a child reads, right? This dependency was significant in our data. Measuring the second factor, dependency on level of phonological processing, demonstrated that indeed this dependency is significant as well. The better a child performs this complex task of complex phonological processing, changing a sound in a pseudo word, the better his or her reading is. And finally, orthographic processing also has proven itself as a significant factor, as a predictor of reading in Russian-speaking children. Here, it's not surprising that the line looks differently in comparison to the previous slides, right? Because we measured here time completion. It means the closer this parameter on time completion is to the left side, it means the faster a child was performing this task. So it means the faster, in this case, the better orthographic processing and the faster reading as well. So we would like to outline and to speculate on the results we collected in the following way. First of all, I remind you the research question that what's in the study, that we wanted to see how phonological and orthographic processing skills as well as age influence reading fluency in Russian-speaking children. And what we've got is that all the three factors mentioned, age, phonological processing, and orthographic processing, indeed predict reading fluency in Russian-speaking children. So, as I think was quite clear from the results as well, higher level of phonological processing speeds up reading, faster performance in rapid automatized naming tasks speeded up reading, and also above phonological processing, and older children read faster than younger ones, which actually is not surprising, right, but still worth mentioning. Thank you very much for listening. I would appreciate your answers, and I'm happy to answer them. And also using the moment of sharing our research with such a great number of participants of the conference, I would like to mention that we're still recruiting participants and we continue this research. So in case you know families with Russian monolingual children aged from 6 to 12 years and who live in Moscow, as the data collected here in Moscow in our lab, please share this info about your research. You might just take a picture of the QR code on the screen and share this info with your relatives, friends, or in case you're the family, please, you're welcome. So thank you very much.
Thank you very much, Nina. So questions, please. Let me see if we have any. Yuri Shtarov has the question.
Yes, thank you very much for a very interesting presentation. I'm sorry if I missed this, but I understood you collected all the lots of variables about these kids, including nonverbal intellect and others. Did any other variables, the ones that you didn't present in your results, correlate with the reading skill, such as nonverbal IQ and or perhaps others?
Okay, Yuri, thank you very much for your question. So indeed, I've mentioned that the test used to measure the nonverbal intelligence of children was Raven matrices, right? So we did not use it as a factor, or even we did not balance children based on the test. We only controlled it, right? That all the children perform within the boundaries of the norm in those Raven matrices,
which
right?
wouldn't stop you from trying to correlate it. Just a comment.
Yes, you're right as well. Yes, thank you very much. Regarding other measurements, no, we did not measure intelligence as such, well, with any other tests. What we're doing right now, which is also part of this research, we measure also whether children have the whether their hearing is all right or not, it's a norm or not. And in this result, what we've demonstrated, all of them were also within the norm. They heard, their hearing is not impaired. I just didn't mention this, probably just, I don't know, did not consider it as this that important here. And other tests, basically, no. So far, we have not implemented other tools.
Thank you.
Thank you very much. Thank you very much for your question.
Thank you. Any more, please?
Can I maybe add to Nina's answer to Yuri's question?
Please, you're welcome.
Yeah.
Yes.
In a previous study, actually, we looked at whether nonverbal intelligence influences reading, and it does. So
thank you for your commentary, Anastasia, because this was just what I thought of maybe adding a bit, because we'll have a flash presentation tonight. Ekaterina Andrushenko will present this data. We also had a couple of studies with the same results, but we tested not children, but adults. And it looks like this nonverbal intelligence, which is actually not just nonverbal, but it is G factor, contributes more to reading comprehension in our case than any other relevant factors, surprisingly. But this is just the teaser of the.
Thank you very much for this comment.
Thank you very much, Nina. Very interesting, and yes, that would be great to see the development of this line of research. And I think it's time for us to close this session. We've done very well, and now we are supposed to have a break until 12:30 p.m. So we can just relax a bit, and we want you back in already 13 minutes time. Then we have the slide session 4, which will be just slightly shorter. We have 4 slide presentations, and after this session 4, we will go for a 45 lunch break and then continue. So enjoy the break and see you soon.
See you. Thank you very much.
All right, welcome back, everybody. I think we can resume, and this is the last slide session. I'd like to thank all the previous presenters for excellent, clear, concise presentations and for being on time. So I hope we can stay on time. This is a short session with 4 talks. I remind all the presenters that the talks are 10 minutes with 5 minutes allowed for questions. And let's start. The first presentation is by Sergey Aganov and Alexander Kornev from Pediatric Medical University in St. Petersburg. And they will be talking about different types of regressions as a text processing skills indicator on example using eye tracking study of reading in 9 to 11-year-old dyslexics. Do we have the presentation? Yes, we do. Please carry on.
Good afternoon, colleagues. Unfortunately, my co-author, because of some family problem, cannot be the presenter, and I will do this instead of him. Our presentation is about some special problem in dyslexics, comprehension problem. Previous presentation make it easier for me to continue about some specific sorry. To tell about some specific feature of dyslexia. Usually, dyslexia recognized as a primarily decoding problem, but some of dyslexics have limited comprehension, and the question which debated many times is the poor comprehension in dyslexics is of primary nature, represents some separate problem, or is secondary nature and related to poor decoding. But first, let's several words. Let me say several words about the classic view on the comprehension, some architecture of comprehension, according to the work of Kinch, Van Dijk, Van den Broek, and many others who study this process. And this view changed to some extent during text processing. Reader not only scan the text, but reader has to construct their own coherent text base from micro and macro proposition. It is only individual process. Different readers can construct different text base according to the same text was presented for reading. And because of that, this process of comprehending is rather complex, and there are some complex model of this text processing. And according to these authors, it is reasonable to recognize the two levels model of text comprehension. There are, you can see on the slide, two levels. The low-level processes, and primarily it is decoding process, phonological recording, lexical access, and high-level processes, which consist of inference making, self-monitoring of contextual relevant of production results of inferences, and finally the creating of coherent propositional structure of the text. And our hypothesis was that the main cause of limitations in comprehension some dyslexics have is the high-level processes limitations. We can see the process of text processing during reading as the sequence of several stages: word reading, sentence comprehension, composition from verbal form to non-verbal form, and after that integrating micro proposition obtained previously, and so on and so on. And as a result, the text-based construction as the set of connections, macro proposition. You can see that this is a rather complex process, and of course related to executive functions. So the aim of our study was to test this hypothesis that poor comprehension in dyslexics is related to a limitation in the high level of text processing. And these limitations should influence the gaze movement patterns during a text reading. You can see this graphically, two possible hypotheses. One, where the comprehension problem recognized as secondary, and another one when two factors, two sources of limitations can be low level and high level process. To solve this problem, to try to shed some light on this problem, was composed two groups of children. One, dyslexic children, which was selected according to the result obtained in standardized assessment by means of reading skill battery assessment, so-called SMINCH. The obligatory condition was 1.5 standard deviation below mean, according to the quotient in this battery, and control group typically developed peers with normal reading. To test intelligence, was used CATEL test, culture-free intelligence test, And the exclusion criteria for both groups present on this slide. On this slide, you can see descriptive information about two groups, typically developed children and dyslexic children. And you can see in all measure they very similar, but intellectual quotient in dyslexics was slightly lower, but normal one. And of course, the reading quotient was significantly lower than in control group. The task in the eye tracking study was to read two expository texts, some descriptive information you can see on the slide. They read it silently in self-paced mode, and eye movement was recorded by SMI machine. Measured of which was analyzed was the next. The fixation length.
Alexander Nikolaevich, you've used up your 10 minutes, so you need to be very fast finishing with the results. You've used all your time.
Fixation and additionally to usual analysis, we made more detailed analysis. We divide the saccade into 4 groups: micro, short, medium, and large, and analyzed their distribution. The same was made with the regression saccades: micro, short, medium, and large length. It was supposed that their role, according to their size, different functional role. And results of our study. This is quite usual results. We found a significant difference in duration of fixation between groups. The same was about count of fixations and count of progressive saccades. There are old news. The same results was obtained in many other publications. But if you can see of more detailed analysis, you can see some new information. I mean that the difference between groups was large in the short progressive saccade. You can see much more in dyslexic and less in control, and vice versa in more long progressive saccade. And you can see illustration of some low-level problem in dyslexics comparatively to control group. The analysis of regressive saccades is the same. The results obtained in this analysis was the same. The dyslexics made more micro regressions and less more micro and short regressions and less medium and large regressions. And on this picture, you can see the difference in high and low level processes. I mean, regressions which dyslexics made was very short, but in control group, we can see much more long regressions. So the conclusion from our study, the most of dyslexics has impairment both in low-level and high-level processes. They have limitations in some high-level processes, such decreased inference making and anticipation capacity, which manifested in short and long, the different distribution in short and long progressive saccade, and the same as for regressive saccades. Thank you for your attention.
Right, thank you very much. A lot of interesting data. Unfortunately, we are out of time. If there is one very short question, I would allow that. Otherwise, we do need to continue. But we will have time to discuss more at the end of the flash talk session. And one obvious question I'd like to maybe postpone until then is whether the high level differences are actually still the consequence of the low differences. Thank you very much again, Alexander Nikolaevich. That's very interesting data.
Thank you.
Yeah, we do need to continue. And the next talk is by Melanie Labouche from University of Maastricht and University of Valencia, with colleagues from the same universities and also from Nebrija University. And Melanie will talk about the impact of capitalization of German nouns on semantic processing. Right, do we have Melanie with us?
Yes, hello.
I thought so. Yes.
Hello.
You can start sharing the screen. Hello. Yes, we can hear you. Can't see your screen yet.
Yes, okay. Can you see my screen?
Yes, yes, yeah. Thank you.
Okay. Hi, my name is Melanie Labouche, and I'm going to present to you today our research about the capitalization of German nouns and their impact on semantic processing. So in most Latin-based languages, common nouns and also verbs and adjectives are written in all lowercase letters. So only proper names are capitalized. So the English verb, the English noun book, for example, is written in all lowercase letters, and also the English verb to go is also written in all lowercase letters. But in German, however, not only proper names, but also all common nouns are written with an initial capital letter. So the German noun Buch, which is book, is written with an initial capital letter instead of all lowercase letters. And as a verb, gehen, which means to go in German, would be written in all lowercase letters. But why do the Germans do this? So does the initial capitalization of the common nouns have any benefit? Or does it maybe help to process the word better in a semantic way? Or is it just a historical legacy? From the theoretical perspective, in current neural and computational models on word recognition, letter case does not play an important role. So it is said that visual input is mapped onto case invariant abstract letter units, and then it's further processed. But these models mainly focus on the English orthography. Evidence for these models has been found in mask priming experiments where target words were processed equally fast, irrespective of the letter case of the prime words. And this was also supported by ERP evidence. However, it has been found out that case-specific information is not always lost. So in a lexical decision task where people had to identify a letter string as a word with brand names, people could detect brand names that were written in the most familiar letter case format faster than a less familiar case format. And in another combined lexical decision and fMRI task that was done in German, common nouns in their most familiar case format, that is in German with an initial uppercase letter, were identified faster and more accurate than when they were written in all lowercase letters. For non-nouns, it was the same, but the other way around. Further, in the same study, the visual word form area has been identified as a brain region that is sensitive to the familiarity of letter cases, in the sense that it is more active for unfamiliar letter case formats than for familiar letter case formats. However, we still don't know what happens at the semantic level. So the problem with the lexical decision task is that in order to decide whether a string of letters is a German word or not, it's not completely mandatory to access any semantic information about that word. So therefore, the measured effects from previous experiments could have occurred because the presented words appeared more visually familiar to the participants than others. For example, the brand name IKEA in all uppercase letters looks much more familiar to us than the brand name IKEA in all lowercase letters. In order to avoid this problem, it's possible to use a semantic categorization task, which is asking, does this word belong to a given semantic category? When answering this question, people need to access their semantic knowledge in order to give an answer. And therefore, they need full lexical access to the word. So this is basically what we did in our first experiment. We presented the people with individual words and asked them the question, does this word refer to an animal? And they had to answer yes or no. As stimuli, we used 100 animal nouns, 100 common nouns, and 100 verbs and adjectives. Half of the words were written with initial uppercase letter, and half of the words were written in all lowercase letters. For the data analysis, we used Bayesian linear mixed effects models, and we found, first of all, that there was a very high accuracy for all responses. For the animal nouns, we found that animal nouns with an initial uppercase letter, which is the typical way of writing in German, were processed faster than animal nouns with all lowercase letters. Verbs and adjectives were processed faster when written in all lowercase letters than initial uppercase letters, which is also the most common way of writing. For common nouns, they were processed faster when written in all lowercase letters than with an initial uppercase letter, which is surprising because this is actually not how common nouns are written in German. So this can be due to several reasons. First of all, there was an unequal distribution of yes and no answers in our experiment, because in a third of the cases, people had to answer yes, and in 2/3 of the cases, they had to answer no. So this might have biased the participants towards a no answer. Then we used lowercase common nouns, and this is actually an orthographically illegal form of writing nouns in German. So therefore, this form of writing could have biased the participants to respond with no rather than with yes. So in order to investigate this more closely, we did a second experiment. In the second experiment, the setup was basically the same, except that we only presented animal nouns and common nouns to have an equal distribution of yes and no answers. And instead of the orthographically illegal all lowercase format, we used an all uppercase format that is actually sometimes used in the German language. What we found was, first of all, also we found a high accuracy for all responses. For the animal nouns, as in the first experiment, we found that when they were written with an initial uppercase letter, it was responded to faster than when they were written in all uppercase letters. And this time also, we found that the same pattern for common nouns. So common nouns with an initial uppercase letter are responded to faster than nouns with all uppercase letters. So altogether, we've seen that previous experiments have shown that lettercase information has an influence on word identification on the basis of the most familiar perceptual form of a word. And the current experiment has shown that on top of that, lettercase information influences the speed of processing beyond visual familiarity in a semantic context. So in the theoretical context, this means that current models of visual word recognition cannot entirely be applied to the German language. This is because these models assume that letter case information gets lost early in processing, and the current experiments have shown that in German, letter case information have indeed an important influence in lexicosemantic processing. So therefore, it's possible that orthographic processing may be language specific. Future studies will investigate whether the processing of letter case information in German will have an impact on the speed of sentence processing. It may also be influenced by reading skills, so developing readers and those speakers who are learning German or individuals with reading-related disorders may have a different approach on processing the capitalization of German nouns. And in the future, it's also necessary to see whether there's a neural region that is sensitive to letter case information in a semantic context. So a candidate for this would be the visual word form area that I mentioned in the beginning. Also, the time course of the processing of letter case information of German words on the lexicosemantic level and the corresponding ERP components are still unknown. So there's still a lot to discover. I hope you enjoyed my presentation of the current findings, and thank you for your attention.
Thank you very much. It was indeed an enjoyable and clear presentation, very interesting findings. We have time for a couple of questions. Any hands? I can see Nina Zdorova has raised a hand.
Exactly. Thank you very much, Melanie, for your beautiful talk. I'm wondering, as a German second language learner, first of all, thank you very much for the outline of your perspective studies regarding the processing of capitalized letters on a sentence level, right? Because indeed, during listening to your presentation, I was thinking that I assume that reading a sentence or even a text on a text level, your results might be different. Because I remember me as a German second language learner, the first rule you learn about German, all the nouns are written as capital letter, right? Yeah. And it facilitates basically your processing and your parsing of a text, because when you just have a look at the text, you immediately create expectations, what you have there. What we, for example, do not have in English, where all the words are written with small letter, and sometimes we have those homophones where do not know whether it's a effect or to effect, a processing or like to process or a process, right? When we cannot distinguish between a verb and a noun, and which is not possible in German. German gives us immediately this information. So thank you very much for the outline of the future research. But I'm wondering whether you think it's possible at all to answer this question, whether capital letters indeed facilitate our processing or not, if in any way for both, for monolinguals, for native speakers of German, and for second language learners of German, this noun written with a small letter is already unusual information. And I think it will immediately impede the understanding, because we expect having nouns in capitalized. Do you think it's possible at all to answer this question?
You mean based on the information that it's unusual that nouns, like for native speakers, for example, that nouns written in all lowercase letters.
Exactly.
Unusual. Yes, the thing is, I think for people that are learning German and that are used, for example, to the English orthography, maybe for them it's less unusual that they see a noun written in all lowercase letters, and they still have to learn these rules according to the German orthography. So I think there's a lot of potential to see when people are learning these rules and whether these rules are really effective in learning German, and
okay.
on
I see, but
they are effective.
I see. Thank you very much. And my recommendation would be that to diversify your second language learners based on the level of English or German, because I think the advanced German learners will immediately be stuck with this problem as native speakers, because this is unusual information. It shouldn't be written with lowercase. It should be capitalized.
Yes, totally. And that's also what you usually learn when you're learning German. What you're learning in the German classes, I assume.
Exactly.
yes, what is interesting is when you're learning this information in the process while you're learning German, and when you detect it as unusual in the end, right?
Yes, exactly. Thank you very
yeah,
much.
Yeah, thank you. There is time for one brief question, if anyone else wants to ask. If not, I will ask whether you think this can be addressed. The question of facilitation through capitalization can be assessed cross-linguistically. For instance, using other languages where sometimes, like English, sometimes nouns are capitalized in certain cases, sometimes are not. Comparing the speed of reading, and also within the language, can you compare generally the speed of reading in German versus other close related languages? Other Germanic languages, for instance, do people read faster in German than other similar languages? Take Danish, for example, or Dutch or English.
Yeah, that's an interesting question. You mean like compare the reading speed of German in comparison to the reading speed of Dutch or English? And
yeah, as long as the word length is matched, for instance.
Yes. I don't know if that was already investigated. I know that this issue of capitalization has been investigated in other languages as well. In Italian, for example, it has been done with proper names because in German is the only Latin-based language that has this property where common nouns are capitalized, and in other languages usually proper names are capitalized. So it has been investigated with proper names, and they have found similar effects, but only for the visual familiarity issue. So
okay. Well, here is an idea for an online study while we're stuck in this lockdown. Just do it cross-linguistically.
Yes, thank you.
Very interesting.
Very interesting.
Very interesting. But we do have to continue. Thank you, Melanie. The next presentation will be by Yelizaveta Sokolenko and Svetlana Malutina from HSC University in Moscow, who will speak about the effects of different types of semantic cues and word retrieval. Who is presenting?
Can you see my screen?
Yes, yes, we can see your screen, but it's not in a presentation mode. Now it is.
Hello, everyone. Me, Yelizaveta Sokolenko, and my co-author Svetlana Malutina are presenting you our research, the effect of different types of semantic cues on word retrieval success in tip-of-the-tongue states. The tip-of-the-tongue state, or simply taught, is an experience when a person has a strong feeling that she or he knows a word, but at the moment it cannot be retrieved. There are several theories why taught states occur, but in our research we focused on direct access theory, which divides into blocking theory and partial activation theory. Blocking theory suggests that words with similar sounds and meanings compete for activation with target words, and changing retrieval conditions can help to resolve the taught state. And partial activation theory suggests that the retrieved word has more activation than its competitors. And due to incomplete activation of the target word, taught state occurs, and additional information about the target word can help to retrieve it. There are many studies that are focused on how different types of semantic cues can resolve taught state, but there are no research that focused on different types of semantic cues. So our research question is what a specific type of semantic cues is more effective for resolving the taught state. We are focused on semantic types of semantic cues, coheponyms and associations. Our hypotheses are we suggest that semantic cues would help rather than interfere with the retrieving target word in third states. This hypothesis would confirm partial activation theory, and the next hypothesis is that cohyponym cues would strongly compete with target word and interfere with its activation. So association cues should be more effective in resolving third states, and this hypothesis would confirm blocking theory. Our stimuli was 102 target words. There were low frequency Russian words, 49 abstract and 53 concrete. About half of them we collected from research Kleiman and Shmonina, and the rest of them we collected by ourselves. For each word we had a definition. One cohyponym cue, which we collected from Ruscale section related words, and one association cue, which we collected by ourselves with the help of different websites, and then we checked them on semantic distance with target words on Rus vectors. Here you can see some examples of our stimuli. Our participants were 19 young adults in age 18-40 years old. We had to conduct our experiment online because of pandemic, and it was programmed on PsychoPy and presented on online experiment platform Pavlovia. In our experiment, we firstly showed our participants a definition of the target word. He or she should name it. And if he couldn't retrieve it, we asked if he or she experienced third state. If he or she asked either no or yes, we showed him or her a cue, association, or cohyponym. After a cue, he or she had an opportunity to name the word again. And if he or she still couldn't retrieve it, we showed a target word and asked if he or she had this word in mind. The results show that before cue presentation, there were 26% of correct responses, 17% wrong responses, and in 56 cases there were no response, and 14% of third states among cases with no response. After cue presentation, there were 17% correct responses after cohyponym cues, and 18% correct responses after association cues. Other results you can see here. Analysis of variance showed that there is no difference in efficiency of cohyponym and association cues. That cues were more effective when the participant experienced a third state, and the presence of third state didn't modulate the relative effect of cue type. The theory of partial activation wasn't confirmed in our study. Semantic cues helped to resolve the third state rather than interfered with word retrieval. And blocking theory wasn't confirmed in our study. Associations were not more effective in resolving third states than cohyponyms. And finally, we have highlighted some limitations which we faced. The first is the frequency of third state was less than we expected, so it costs less statistical power than we expected. And in future research, we would recommend more trials or preliminary normed stimuli. The next is some strategies that we faced in online experiment. For example, some participants opened queues before making any response that caused some wrong samples. And in future researches, we would suggest to use some other semantic types of queues, for example, synonyms, hyponyms, and or collocations. And now we continue to collect data from other participants to get more representative results. That's all. Thank you.
Thank you very much. Very clear and concise presentation. Do we have any questions? I think we have one. We have a question from, or a comment from Anastasia Lopukhina. Anastasia?
Yes, hi. Thank you for a nice talk. I have a question. Maybe you can speculate why this tip of the tongue state happened in 14% of cases. So it's not very, it's quite a rare state, right? Maybe it cannot be assessed in an experiment like that, or maybe people just have the state rarely. So what's your ideas why it's so rare?
As I have said, the first reason is our stimuli, which caused 26% of correct answers, and it is a high result because some stimuli were often be named by almost every participant. So I think that in future results we would we wouldn't include this stimuli in our future research. And I think that the wrong samples, which participants were used some strategies, they didn't name a word that caused such low percent of thought state. That's all. I think the main reason is our stimuli. But in previous researches that were English researches, the percent of thought state was about 40.
Thank you. Thank you.
Right. Thank you. Very interesting. Any other questions or comments? Obviously, different topic to study in a lab setting, trying to make people to have tip of the tongue states. What is your prediction for other types of stimuli that you are going to use, synonyms, for instance, and others? Do you think you can get better, higher outcomes for those?
Honestly speaking, I don't know because we have to try to use them. I don't have any prediction because there were no any researches on such types of cues, and so I have no predictions.
May I add something as a co-author?
Oh yes, please, Svetlana.
Yeah.
Yes,
so I personally have very high hopes for collocations as a cue type. So a cue that is frequently used with the target word. So not only semantically related, but also frequently co-occurs with it. But like Yelizaveta just said, there are no previous studies using collocations, so it's only a hypothesis to test. And also it is difficult to develop stimuli where we would have collocations for many stimuli words, because not many nouns have very strong collocations. But I personally think that perhaps this co-occurrence together with semantic relatedness would be something that would make collocation cues superior to other semantic cue types.
Right. Yes. Thank you. Thank you very much. Interesting. So that's a lot of space for pioneering research then. That's a good side of it. Thank you kindly. And let's continue to the last talk of the session. And this will be on systematicity in language by Hannah G, Monica Tamaritz, and Richard Shilcock. I understand that Richard was going to give that, if I'm correct. Hello, Richard. Yeah, we can see you, and you can start sharing your screen.
Yeah. Share screen.
You have to choose the right screen in Zoom.
Yeah, I'm just looking at that. Oops. Here we are.
Yep.
Okay, that should be it.
Yes.
Yeah.
Yes.
Okay. Well, first of all, I'd like to thank all of the organisers for organising this, and it's good to be here. It would be nicer to be in St. Petersburg, of course. But so what I'm going to talk about today is the systematicity in language that people have been looking at these last few years. So all of us are aware of words like sneeze and snore, where the words seem to mean almost the same thing to do with the nose, but they kind of sound a little the same because they both start with sn. So the systematicity I'm talking about is a much more widespread thing than this. It's much more kind of distributed across the lexicon, and it's much more in line with the topographic kind of processing that we know the brain does. So this is the first slide. So we're looking at words that sound the same and tend to mean the same. So on the left here, what you've got is a group of words. So in these studies, we use hundreds and hundreds of words from the lexicon. And what you see here is a small toy kind of version of that. So we've got the words dog and cat and sneeze. And what we're interested in is the distance in terms of the phonology from one word to all the rest of the words. So the distance here, dog to cat, we can work that out using Levenshtein distance, the number of different edits in terms of the features that you need to get to turn the phonology of a word like dog into cat. Excuse me. So crucially for this study, we were looking at the language of Korean. We were interested in that because Korean allows you to do a lot of interesting things, as we'll see. So moving over to the right side of the screen, what we've got here is the same network, as it were, between the meanings of those words. We can get the meanings from something like WordNet. We can get the distances, but what we prefer to do is to quantify that, to define the meanings in terms of the vectors that one gets from a large corpus of the language. So you're defining the meaning of dog in terms of the rest of the words that all occur around each token of dog. And so again, we can get the distance between dog and cat. And so what we do is to line up all of the distances. So this is the distance in terms of speech sounds here, and the corresponding distance here is just there. And so if it were the case that the language was completely compositional, if the language was completely transparent and we could just predict meaning, what we should find is isomorphism between the web, as it were, here on the left and the web on the right there. But of course, the language isn't a compositional thing, and the correlation we get between the distances is not the correlation that we get between the distances isn't one. The thing we find here, the result we get here for Korean is small but really significant. It's interesting comparing it with the rest of the languages that have been with the rest of the languages that have been investigated in this way. Only a small number of them have used phonology to do this. Most of them have used the proxy of the actual orthography instead of the phonology. And all of the previous studies have been with the languages of Europe. So we were interested in a very different language, and the thing we find here is the systematicity there is really significant. So words that mean the same tend to the words that tend to sound the same tend to mean the same, and the level of correlation we get here is about twice that of the rest of the languages that have been looked at. Although one can't really compare across the languages like that because the samples are different. So the interesting new thing I want to stress here is that you can slice up the sample that we got here at the top. You can slice it up in lots of different ways, and each way you slice it up, you see that the systematicity is still there. It's a really kind of the systematicity is a really distributed thing. So we sliced up the sample in terms of the words that came from the Chinese influence there, and the words that were the pure ones there. We sliced it up in terms of things like onset, the nucleus, the coda, and the rhyme, and all of those things also show the same kind of systematicity with meaning. We slice it up in terms of the syntax with nouns and verbs, and smaller subsets as well, like onomatopoeia or the loan words. We also slice it up in terms of different frequency strata, and in all of these things, the systematicity is there, except in the really lowest of the frequency strata. So this is a new thing, that the systematicity we see is really a pervasive thing. We've also carried out this kind of approach, and this is a new thing. We've done this with looking at the actual orthography. So Korean is special in these terms in that the orthography, you see the letters here, the orthography was constructed very consciously something like 500 years ago to reflect things like the shape of the lips, the position of the tongue, the mouth, and things of that sort. So what we were doing is really applying the same kind of study to map the corresponding distances, but the distances here are the distances, the visual distances between the letters, which you can calculate using something called Hausdorff distance. It's a kind of crude first attempt to do that. And the distance between the canonical pronunciations for each of the letters that you see there. And what you find here, predictably, because the orthography was constructed to be like this, what you find is a surprisingly high degree of the systematicity between the canonical pronunciations and the letter shapes. It changes for different ones of the fonts there. This is the best one there. You also get this effect for things like shorthand, like Pitman's. We looked at the Roman alphabet, and it is there. It's very small. It is significant for certain fonts. So what's underlying this is this very pervasive long-tail distribution that you find just just all over the world and just all in language as well. Just to explain it, if you look at frequency of words, you have a very long tail of fairly low frequency words, and you just have a small number of words like the filled pause, the function words. You just have a very small proportion of words of really high frequency. So I think it's a diversion to ask if this a Yule distribution, a geometric curve, an exponential, all those sorts of things. All you need really to know is the thing has a long tail, and these long tail distributions are just everywhere. If we look at what's going on with phonology, you see it's the same, that the more you go into the words like this, there are a really small number of words that are very short, that we kind of reduce lots, and that are the words that are just easier to say. As you go down the tail here, you get the weirder words, the harder to say words. These kinds of studies all concentrate purely on the monosyllabic words, but clearly off the end of the scale here, there are longer and longer and longer words. If you look at meaning, what's going on here, the infrequent words don't have a lot of opportunity to occur next to lots of other words. So the context vectors they have are really quite sparse. The more frequent the word is, the more the contexts differ. Until you get to things like function words and the filled pause, the really frequent words, where they just occur in lots and lots of different kinds of contexts. And so this is a new kind of claim we want to make here. The more you go up here, the more you're kind of depending on the processing of pragmatics to really understand what's happening. This is the largest of the contexts that you can have. And what we want to say is that, as opposed to that kind of involving lots and lots of work, if you're bringing the biggest context to bear, the pragmatics to bear, there's just less work there. So when we think of things in interactive activation terms, you would think, oh, there's lots and lots and lots of these connections here. That looks like lots of work. But if you think of it more in terms of the complexity of the system here, there are just lots and lots of these kind of criticalities that are just poised there just to spring into action. And so you get a lot of those are just really efficient things to use. And so what we really want to see to pragmatics, when you're talking about rare words, long words, these are just hard work. So just to conclude here, the systematicity we've been looking at is all through the language. It's very distributed. It's useful potentially for language learning in infancy. It's probably useful for processing because it's tapping into the kind of topographic processing that we know is just all over the brain. Long tail distributions seem to mediate the systematicity I'm talking about here. So we can ask, what's really kind of in play here? Is there some kind of universal that captures, that's the most efficient, effective way of trying to investigate all of this? So the meaning of universal that we usually have in psycholinguistics is one we've taken from the linguists. It's a really abstract thing. The kind of universal we're using here is something explored by the philosopher Ival Ilyenkov, where a universal can be a material thing. And the material thing that we're stating underlies all of this. We go right back to Zipf, who said, it's just effort, it's the work done. Sometimes for trying to perceive language, we might think that just means the work you can see with the lips and things, but now there's been this kind of sea change to talking about the listener trying to to actually predict things. And so it's not always work that you can see, but it's work that the listener is able to think will happen. So the work done is the thing that kind of explains all of this, I think. So I'm going to leave it there. Thank you again for listening.
Thank you very much, Richard. Very rich and interesting presentation. I think we have some questions. I can see one from Maria Fleckman. Maria, please.
Yuri, I think something is wrong with the sound, because it seems like I hear that you are saying something, but it's very, very quiet.
Oh, hello, sorry, my microphone
now
seems to have been off. Thank you very much, Richard. This is very interesting. I think we have some questions. Maria Flaxman has a question. Please go ahead.
Okay, thank you. Richard, thanks a lot for your talk. I'm a researcher at the Friedrich Schiller University Jena doing a postdoc on diachronic iconicity. I was very much looking forward to your talk, as it makes me really happy to know that people research systematicity in language from various aspects. And I was just wondering if you study the diachronic side of the problem as well, because it turns out that iconic sound meaning mapping has different prominence and different strata of language. For example, you are probably very familiar with the Jespersen article on the correlation between E sounds and small size. And I have been looking at this problem from the historical point of view, and it turns out that this correlation is a very recent phenomenon in English language. For example, words like tiny, teeny, they acquired this E sound due to regular sound changes that had preceded these processes, and you don't find such words in Old English, for example. How do you regard this problem?
I think it's a really interesting issue. I sort of, for a long time, I've wanted to think in terms of what kind of etymological strata are there, the words we get from Old High German and things of that sort, and just whether it's present really in the processing that we do. I think it's really interesting. I think it's difficult to do that work because we're not entirely sure of the pronunciations the further you go back. We attempted a little bit to tackle it in Korean because what we were looking at there was the Chinese influence there. So you can kind of distinguish things a bit there. And what we found again was that it was, the systematicity was really equally strong in the pure Korean part of the sample that we had, and the Chinese as well. There is certainly, I think, to change to the letters of the alphabet, I think there's a clearer diachronic picture there, because some of the sounds like the w and things like that kind of we have a clearer idea of where they kind of came into English, and the letters that were produced or kind of joined up to make them. So I think we can say that with regard, we can look at that diachronic issue with regard to the letters. As to the sounds, again, I think another limiting factor is it's harder to get large corpora when you go back in time like that. It's really the Bible you're looking at there.
Well, I agree to some extent. If you're looking at Old English, I have found about 300 imitative words, onomatopoeic words in the whole corpus.
It's really interesting to do that.
So it's limited indeed.
Be extremely interested certainly I'd be extremely interested to talk offline about this.
Okay, thank you.
Yeah, thanks.
Right, thank you very much. It's a very interesting topic. Unfortunately, we seem to be out of time already, and maybe we ought to wrap up, but we will have time for additional discussion
Yeah, I'll stop sharing. Yep.
After the flash talks, and now I'm sure we all want to have a break before them. Thank you very much, Richard. Very rich topic.
Thank you.
I look forward to hearing more about this from you. And I think we are done with this session. We have flash talks in 40 minutes at 2:15 of Moscow time, -3 hours for UK, -2 hours for Central Europe. And thank you very much to all the presenters for excellent talks and for being largely on time. And we will be back in 40 minutes. See you all soon. Thank you.
All right. It's 2:16 p.m. St. Petersburg time, and the lunch break is over. I hope, yes, everyone is back, and we expect more participants to join us, and we are starting our second Flash Talk session. I will remind that the timing is 3 minutes for the presentation itself and 2 minutes for a couple short questions. So we're gonna be pretty accurate about that. And I'm announcing the first presentation by Anna Zhuravlyova and her colleagues from Higher School of Economics. And the title is Development of Novel Word Acquisition Paradigm for Non-Invasive Brain Stimulation Studies.
Hello, can you see my screen?
Yes, everything is seen.
Hello, dear colleagues. Me, Anna Zhuravlyova, and my co-authors, Svetlana Malyutina and Katerina Stupina, are going to present our research, development of novel word acquisition paradigm for non-invasive brain stimulation studies. A lot of research can induce effect on language performance in healthy individuals, but often these studies find no effect of stimulation, and part of these results can be probably explained by the linguistic tasks being too easy, so participants always perform it at ceiling. So the field of non-invasive brain stimulation needs sensitive language tasks when the performance that have room for modulation by non-invasive brain aimed to develop such tasks. We have prepared an explicit in one of our previous studies by Katerina Stupina. L1 stimuli consisted of 80 Russian nouns selected from the database for psycholinguistic stimuli. Both pseudo words and L1 stimuli were automatically divided into two lists of 40 words, as we have two experimental sessions in our paradigm. Stimuli parameters were counterbalanced across stimuli lists, and an individual stimuli list was automatically generated for each participant. Our experimental paradigm consisted of two experimental sessions as typical for non-invasive brain stimulation studies. Each session includes an acquisition session where participants learn novel words and their translation, and then an immediate testing session measuring acquisition success, and then a delay testing phase on a separate day measuring consolidation success. Each of the phases consists of 3 linguistic tasks as present in the slide. To date, we have conducted an online validation of the paradigm in 5 participants. Taken together, participants performed well in most of the tasks, with no floor or ceiling effect.
And I'm sorry for interrupting. It looks like there are some technical issues on your side. Could you switch off the
well
camera?
enough to recognize them, but still they were unable to reproduce them properly.
And if you can hear me now, could you please switch your camera off?
Overall participant performance
unstable.
The camera off. Can it continue?
Yes, please try to continue, and well, we can try to figure out the things that were missed during the questions.
So, enhancement in overall participants' performance in the delay testing phase indicates that novel word forms have become partially consolidated by the next day. So our experimental paradigm has proven to have an optimal difficulty level for future non-invasive brain stimulation studies and should be sensitive for modulation by non-invasive brain stimulation on language performance. Thank you for attention.
Thank you very much. Any questions, please, or commentaries? I think we started experiencing the issues on the methods section. So, well, Yuri Shtarov has raised his hand, so please go ahead. Yuri? Yuri, do you want to ask something? Hello? Or is it something wrong on my side as well? Apologize, I will try to shift to the mobile internet, so it might take a few moments.
No, we can hear you well. Probably it's something from Yuri's side.
Sorry, I was completely off. I was completely out, and my question was whether if because we missed because of the bad connection some of this. What are the most specific features that make it is it the learning or the testing that makes it a better paradigm?
In accordance with our aim, the task was to first to the learning phase where so we selected enough words so it would not be too difficult or too easy to learn such amount of words, and we selected learning methods and learning tasks that would not be too easy or too difficult to complete.
Right. Okay.
So,
well, yeah. Thank you. You may have seen some of the talks from our lab where we used up to 20 words and also cognition recall, semantic decision, and semantic matching tasks that worked quite well, being sufficiently difficult. So I think this supports it. While the lexical decision was probably the most useless of all tasks. So it's very sensible that you skip it. Thank you. Apologies for the issues.
Thank you. I think we can try and compensate these issues when we have some extra time during this session after the main part, after the presentations themselves. I think we'll have maybe a couple of minutes for that. So now we have to go on, and the next presentation I'm announcing is by Yulia Nenasheva, Implicit Prosody Hypothesis in Reading, Talker to Listener Distance Effect in Intonation Contour. And thank you once again to Anna Zhuravleva.
So, can you hear me?
Yes, we can hear you.
That's good. So probably I shouldn't turn on the video.
I think it's gonna be safer. Yes, if you can just present like that, that would be good.
Here we are. So nice to hear everybody. It's not about seeing, but more about hearing everybody. Nice to hear everybody. Thanks to everyone for the very interesting presentations. So I hope mine will be as interesting. So my presentation concerns implicit prosody hypothesis in reading. This is a talker to listener distance effect in the intonation contour. So the implicit prosody hypothesis suggests that the default prosodic contour is projected onto the read phrase, not as the translation of the read material into the acoustic form, but rather priming the listener's interpretation of the message. And we'll say that there must be difference between actually calling to someone and reading about somebody calling to someone. So we suggest that such impression is caused by some specific variation of prosodic means, and those means are not necessarily pitch means. So, as pitch means are concerned, we should say that stylized trajectory of in polling sample, and we had two samples. We had sample 1 polling from the distance, 373 utterances, and just simple imperatives, 373 utterances. So we have put them through the acoustic analysis, and we have got stylized FO trajectory, and those contours and the prosodic characteristics showed some very interesting results. So I would like to illustrate. I'm sorry. I would like to illustrate how this sounds. So we had polling from the distance, and utterances. Sorry. Come in. And typical imperative utterances. Come in. So samples show that the prosodic means that show significant differences are intensity range. They also show a bigger standard deviation in this particular prosodic parameter. Then distribution of intensity within the utterance. We know that Q2, quartile 2, is different. That shows some significant statistical differences in both samples. So, and both parameters are bigger in the cooling sample. There is also greater internuclear duration in this sample, and there is flatter intonation contour in this sample. So the range of FO is much smaller in the calling from the distance sample than in usual imperative utterances contour. So which means that, on the one hand, our findings disagree with findings from Fox et al., who represented research concerned with actual shouted from the distance utterances. So they said that there is much variation in the intonation contour. We didn't find that much variation in the intonation contour, so the range was much narrower. And at the same time, we found something which supported Bramlin et al. In 2002 findings, who said that talker listener distance effect can be influenced by non-pitch features. So in our case, it turned out that the impression of polling is created by prolonged duration, by prolonged pronunciation, length and duration of syllables, and the sound and the utterances sound as if they are coming from greater distance than they really are. At the same time, the variation in the tone structure is much less, and it also adds to the impression of gradually decreasing far away shouted speech. So somehow it shows that when we are reading, we are not necessarily following the specific structure, the specific phonetic and prosodic and intonation structure, intonation contour, but we produce this impression by some other means, and those means are loudness, duration, this is length of pronunciation, and smaller or flatter intonation, flatter pitch variation. So thanks everybody for listening to my presentation. I hope I did it well.
Thank you. We are slightly behind the time, so I can only allow for one short question, if there is any. Let me see. No questions, so I think we can just delay it a bit for till the end of the session. So thank you once again, and let me announce the third presentation in this section. Grammatical Roles Assignment in Russian-Speaking Children by Irina Korkina and colleagues from National Research University Higher School of Economics.
Good afternoon. Is everything working?
Yes, everything is working. Good afternoon.
Okay. Let me start presentation. So, Slobin and Bever study showed that in language with free word order, children until the age of 4 rely on canonical word order rather than inflectional cues, and are more likely to assign the role of subject to the first noun, regardless of its case. In our study, we wanted to see if 3 to 4 years old children, Russian-speaking children, would also rely on word order and make less mistakes while assigning subject and object roles in sentences with direct word order, which in Russian is subject-verb-object, or SVO, rather than in sentences with inverted word order, or OVS. We also wanted to see if 3 argument sentences, with the role of third argument being either location or instrument, instrumental argument would provoke more mistakes in children until the age of 6, because in Russian instrumental case is usually quite last. By the age of 7, this difference should have leveled out. Overall, 201 children ages from 3 to 7 participated in this study. They had to complete sentence comprehension and sentence production tasks. In sentence comprehension task, participants had to match one of 2 pictures to audit represent a stimulus sentence. And in sentence production task, they had to describe pictures similar to audit represent a stimulus sentence that was describing another picture. Stimuli sentences varied in number of arguments, 1, 2, or 3, type of argument, location and instrument, and word order, direct or inverse. Also, location argument had locative prepositions before them. Both tasks were presented on a tablet. Answers in comprehension task were automatically recorded, and answers in production task were audio recorded and later coded by a linguist. We computed generalized linear mixed effect model and find out that accuracy in both tasks and in every sentence type grows with age, as we expected. Also, as we expected, 3 arguments sentences were harder to complete than sentences with 1 or 2 arguments. And there was no difference between sentences with 1 or 2 arguments and no specific interaction with age. But surprisingly, we found no difference between types of arguments and no difference between word order sentences, and no interaction with age either. Therefore, our expectations that Russian-speaking children would make more mistakes in sentences with inverse word order were not met. And Russian-speaking children begin to use morphological cues for grammatical rows assignment already by the age of 3, contrary to Slobin and Bever results. One possible explanation for this might be that most nouns are marked by case in Russian, more nouns than in Serbo-Croatian language, which was used in the original study. Thus, it makes Russian language set of rules more strict and easier to acquire by children. Besides, while third argument provoked more errors in children, there was no difference in accuracy between their types. And one possible explanation for this might be that we used location arguments with locative prepositions before them, and they're very complicated and might not be acquired by the age of 7. And that's all. Any questions?
Thank you, Irina. Yes.
Thank you.
Ladies, any questions? There is a hand from Ekaterina Stankova.
Very well.
Am I right that in your experiments, word order didn't affect the sentence comprehension in children?
Yes, basically yes. At least the accuracy in sentence comprehension task was not affected at all. As you can see there is no significant difference.
It is very interesting. If you can share the link to your study into the chat, it will be great.
Our study, I think we have only thesis on this point.
Okay, I will read it.
Okay, thank you.
Thank you.
Thank you very much. I'm inviting the next presenter, who is Ekaterina Andrющенko from St. Petersburg State University, and the presentation on the topic, does metacognitive regulation of emotions contribute to the understanding of ambiguous texts?
Hello, dear colleagues, and our study about contribution of metacognitive regulation of emotion in understanding of ambiguous text, and my co-author, Olga Sherbakova. So, emotion play an important role in solving various cognitive tasks. They can improve cognitive process and guide readers in developing a coherent representation of the situation described in the text. Previously, the intensity of emotion was found to be linked to reading comprehension. Hence, emotion can be important in understanding ambiguous texts such as fables. Understanding of these texts require both development, conceptual thinking, and system of cognitive and affective regulation. Our studies suggest that metacognitive regulation of emotion, emotional intelligence, and theory of mind contribute to the process of understanding of fable geese. And 70 volunteers who were native Russian speakers participated in our study. We used in the deep semi-structured interview based on 9 result fables, 3 sets, 3 fables each. The task was to interpret each fables and formulate its gist. 2 experts scored each interpretation, 0, 1, or 2, depending on whether it was concrete or generalized. 2 out of 3 fables in each set were similar in meaning, while the third one was interfering, which means it's only resembled the previous 2 informal, non-essential characteristic. First, participant discussed the meaning of each fables of the geese with the interviewer. Then, participant combined 2 out of 3 fables together. Questions we ask in an interview concerned both meaning of the text and the emotional attitudes of participants towards fables on their characteristic. Additionally, participants were administered several questionnaires and tests to measure emotional regulation, emotional intelligence, theory of mind, and IQ. So the graphs show distribution of scores for understanding depth and distribution of score for fable pairing. Notably, the majority of participants did not score beyond common understanding of the text. Most of the scored 0 or 1 for understanding and 0 for fables pairing. This suggests that understanding of such texts is a complicated cognitive task. The results aligned with the previous findings, including research that used different materials. Regression analysis did not show any significant contribution of affective process to understanding of fables. However, we found that IQ contributes to the depth of fables understanding and examples 12% of the variance. These results suggest much lower correlation between understanding of ambiguous texts, IQ, metacognitive regulation of emotion, and theory of mind than one expected. While IQ seems to be the closest psychological constructs of the 3 of text understanding. And the main conclusions of our research you can see on the slide. Thank you. I show you it again.
Thank you, Katerina. Perfect timing. So if we have any questions, let me see.
I think Yuri Yurich wants to ask me about.
Oh yes, there is a yes.
My connection works. Very, very interesting. Can I ask you? Sorry if I missed it. Who were the subjects, the young adults? Were they university-educated students or?
Yes, it was students and all of our participants.
Right.
So these students, are people besides maybe 3 or 4.
Okay, so this is quite scary. If people with university education, if most of them cannot even comprehend metaphoric meaning of a fable, that's, yes. That explains a lot about the society we live in, right? Right.
I don't know how I can explain that, but it's really scared, and it's so strange for us that we have these results.
Right. Okay. Thank you very much.
There is a question from Nina Zdorova. Just let me maybe scare you a bit more before I give a word to Nina. I would just like to add this. These are the results that keep being replicated and replicated. This is not the first study that shows the same things. So Nina Zdorova was the first one.
Thank you very much. Thank you very much, Katerina and Olga as well. My question actually continues the previous question by Yuri. First, whether those students were students of literature studies, philologists, or for example, mathematicians, did you do any stratification in terms of their program, field of study?
It was different studies, and some of them was psychologists, and it was profession will connect with the mathematics and so on.
Okay, I see. So on the merge of humanities and science, right? Okay,
Yes.
and my next question, if I may ask, is regarding the ambiguity of text. Did you measure, I have no idea whether those tools exist to measure the ambiguity of the text, to understand whether it's more ambiguous or less ambiguous. There is like maybe a certain parameter, the number of idioms or the number of concepts incorporated there. Is it any tool to measure it?
Oh, it's a good question. Thank you. And how I know, before all fables, there were study about measuring fables which we use, and maybe Olga Vladimirovna can talk about that because her student.
Yes, thank you. Just maybe speed up. I will just step in.
Yes.
From what I know, there are no formalized tools for this kind of assessment. Probably what we can do, and this is what we try to do at some studies, this is just the expert assessment, but also this is not the most objective and not the most reliable tool, but this is a very good point. And probably we can develop something for differentiate the text. That would be of help.
Thank you very much. I imagine how challenging it is. Yes, thank you.
Thank you so much for your question. Maybe we can discuss more later. And now we are going to listen to the next presenter, also from St. Petersburg State University, and this is Tatiana Isaeva. And her topic is digital or printed, interaction between text format and its understanding. We already can see the presentation.
Can you hear me?
Yes, everything works.
Okay. Hello, dear colleagues. My name is Tatiana Isaeva, and the topic of my flash talk is digital or printed interaction between text format and its understanding. So, the digital environment has unique requirements for reading. The level of understanding of a text depends not only on complexity of information itself, but also on physical properties of its carrier. For example, in digital environment, it's more difficult for us to assess the volume of the text. Moreover, hypertext due to a higher cognitive cost of reading in digital environment. Every time when we see a hyperlink at the text, we decided to click on it or not. Increasing the time people spend in the digital environment leads to a skim-through reading strategy. We start to quickly scan the text on the screen instead of reading into it. So, our main hypotheses are that in digital environment, the level of understanding will be less than in printed environment because of higher cognitive load on the reader. An additional hypothesis is extra materials to printed text will be used more often than those available through hyperlinks in the digital environment. The sample included two groups of 20 people, to an experimental group which was presented with the text in the digital version with extra materials provided by hyperlinks, and a control group which was offered the same text in printed form with endnotes. The study consisted of 4 stages: assessment of psychometric intelligence with Raven's matrices, reading the text and answering questions with options for assessing the level of understanding, and after that, each respondent answering question of semi-structured interview also aimed at assessing the level of understanding. So, to test first prediction, we compared the group by the number of mistakes they made when answering written questions, and the level of understanding based on interview assessments by experts. None of the test revealed statistically significant differences, and to test the second hypothesis, we compared the group of the amount of usage of extra materials, and obtained results show that participants use extra materials more often at the printed format. So the level of understanding of the text was not affected by the format of its presentation. This result contradicts our main hypothesis, and it's not consistent with previously reported findings. But the higher frequency of using extra materials for printed text might be an indicator of higher cognitive cost of reading the digital text, provided some support for our initial hypothesis. So thank you for your attention.
Thank you very much, Tatiana. Any questions, please? Looks like no questions. Everything was pretty clear. I can just add that the extended version of this presentation can be found on our website. So if anyone is interested, we can provide some extra materials as well. So thank you once again. And I'm inviting, pardon?
Thank you.
Thank you. I'm inviting the next presenter, Nina Zdorova from National Research University Higher School of Economics. And the topic is how do Spanish natives and Spanish learners resolve pronominal anaphora?
Yes, thank you very much. Just let me share my screen. Sorry for that.
All right.
Great. So my talk would be rather informal, and I would ask you to look at the following example. This is Joey. Joey participated in elections. He won the majority of votes. If we want to say the same in Spanish, it will look in the following way. Joel participó en las elecciones, él ganó la mayoría de los votos. In both English and Spanish, everything is quite clear here. We have one animate subject, Joey or Joel, and then a personal pronoun, he or él, that refers to the only subject that we have, right? However, in Spanish, this expression may also look differently. Namely, instead of using an overt pronoun, él, we might just omit a pronoun, and this is a null pronoun, just ganó la mayoría de los votos, and this sentence has the very same meaning as the previous one. So let's have a look at the following. If we add one more component and would say that Donald, he was well prepared for his, in this case, in English, we already have an ambiguity. Who bet who, right? In Spanish, would be Joel derrotó a Donaldo, and then we can decide whether we use an overt pronoun, él estaba bien preparado para eso, or we use a null pronoun, estaba bien preparado para eso. Then who bet whom again, right? And whether it's different if we use a null pronoun or overt pronoun. According to the position of antecedent strategy suggested by Carminati in 2002, in null subject languages that allow an omission, in prodrop languages that allow omitting a personal pronoun and use a null pronoun instead, this will look as follows. An overt pronoun, in this case, él, would refer to the object antecedent of the previous clause, so él is Donaldo, whereas null pronoun would refer to the subject antecedent of the previous clause, so in this case, Joel. We decided to test this hypothesis, and for this we collected data of 42 Spanish second language learners with Russian as mother tongue, and as control group we had 90 Spanish native speakers from Latin American countries. All of them performed a word-by-word reading, a self-paced reading task. They were reading pairs of sentences where, just in our case with Joel and Donaldo, there were two animate entities and then either an overt pronoun or null pronoun. So we had 4 conditions with null pronoun subject antecedent, overt pronoun subject antecedent, and the same for null pronouns, right? And our results demonstrated that in case of second language learners, there are no significant differences in reading those different types of pronouns referring to different antecedents, whereas in Spanish native speakers, there is a significant difference. And we can interpret the results obtained in line with the previous studies that have claimed that indeed native speakers of prodrop languages tend to have this resolution bias depending on the form of pronoun, on syntactic role of the antecedent, whether second language learners and heritage speakers do not demonstrate this bias. So Our conclusion is that this precision of antecedent strategy might work in native speakers, but still questionable in second language learners. Thank you very much for your attention. I will be happy to answer your questions if there are any.
Thank you so much. Perfect timing. Any questions, please? Can I briefly ask you about the maybe practical outcome of these results? They look very nice.
Yes, thank you very much for this question. Indeed, the practical application would be, first of all, I would say in interpreting and translation studies, as well as second language learning and teaching. As there is still no rule, if we open any grammar on prodrop languages, on Spanish and Italian, how to explain to second language learners what pronoun means what, in what cases we use null pronoun, in what cases a verb, and how do we understand it correlated, right? So this research would be really useful for descriptive grammar, for teaching and learning, as well as I've mentioned interpreting and translation. I just imagine an interpreter interpreting simultaneously the case of Joel and Donaldo. And if it's not clear who bet whom, and the person does not know a context or the context, right? So then the whole translation would be completely wrong.
Thank you very much.
Thank you.
And I'm inviting the next presenter, Kirill Gavrilchenko from Kursk State Medical University, with a presentation, Speech Dysfunction with Damage to the Subcortical Structures of the Brain as a Result of the Ischemic Stroke. Yes, the presentation is on. You can start now.
I want to tell you about speech dysfunction due to the subcortical brain structures damage in ischemic stroke. Research sample and methods. The research experimental sample included 17 patients diagnosed with ischemic stroke. The localization of the abnormal focus is the subcortical brain structures. Research methods. Monreal cognitive assessment, 10 words method, observation, qualitative analysis, neuroimaging, Spearman's correlation coefficient. Results. Naming. 1 out of 3 points in 88% of the trial subjects. Phrase repetition. 0 out of 2 points for 100% of the subjects. Speech fluency. 0 out of 1 points in 76% of the subjects. The mean grade for 10 words method is 3.6. A relation between the parameters speech function and memory has been determined. Spearman rank R 0.59, P-level 0.01. Qualitative analysis has revealed additional features. There is difficulty in choosing necessary words. Patients cannot fully reproduce the sentence proposed for repetition. There is difficulty in starting to build a phrase. Conclusion. The market futures can be interpreted in the following way. Difficulties in nominating objects, choosing right words, and starting to build a phrase are associated with the defect to extract the necessary concepts from semantic long-term memory. The main factor is the connection disorder between the subcortical structures and parietal temporal occipital zone. In addition, the difficulties in constructing sentences are associated with separation of the subcortical structures from the frontal areas, which have a regulatory effect. Thanks for attention.
Thank you. Any questions, please? Maybe I can ask one. I'm sorry if I just missed that. What were your predictions What were your hypotheses? Kirill, can you hear me?
I have a problems with speakers.
Yeah, I can see in chat. Okay, I will type that.
One second, please. We think that
if it's easier for you, we can postpone this short discussion to the end of the section. Will it be more comfortable?
Okay.
Mm-hmm. Okay, then we can come back to this question again. Thank you. And I'm announcing Valeria Pali from Tomsk State University with a presentation, The Cognitive Processing of the Grammatical Gender of Russian Nouns by Russian natives and Turkic and Russian bilinguals. Okay, we already have the presentation. Thank you. You can start.
Good afternoon, dear colleagues. Can you hear me?
Yes, everything is heard clearly.
Okay. I'm happy to present our study, which develops the bilingualism research in linguistics, as well as the research on grammatical gender. The Russian and the Siberian Turkic languages are not studied enough at those points, and we assume the interaction between those languages might reveal many peculiarities, as Russian has 3 grammatical genders and Turkic languages do not have a grammatical gender system. We aim to analyze the influence of the prime and social stereotype, which might be contained in semantics, on the cognitive processing of gender-opposed nouns in Russian. We also want to find out whether the analyzed influence is universal or it interacts with the bilingualism factor. We used the method of behavioral experiment, and we measured reaction times in lexical decision task, in which we used 4 independent variables, which are type of grammatical markers, type of priming picture, and the sphere of use, and the native language, whether Russian or one of the Turkic. The results of the experiments show that the factor of the grammatical marker is important for the natives of Russian, is important only for the natives of Russian. The female sphere is processed faster than the masculine sphere by both groups of participants. And there was no interaction found between linguistic and social factors in the group of natives, but such interaction was found in the group of bilinguals. The results of the study show that priming image affected only the group of bilingual respondents. The reason is priming activates a reference which native speakers of Turkic language build for themselves when studying Russian. We assume priming cannot affect this connection for Russian natives, but such connection also exists. Thank you for your attention.
Thank you. Questions, please? Yuri Shtarov has one. Please go ahead.
Yes, thank you very much. I'm sorry if I missed this. What was the level of bilingualism in your bilingual subjects? How late did they start learning Russian?
Well,
I'm honestly surprised because I always thought this would be near-native or native, or fully balanced bilinguals. I thought they would be.
Yeah, they are. Well, Turkic languages are heritage, so they started speaking Russian in childhood.
Right, and they're still influenced. All right, yeah. Thank you.
Yeah. Thank you.
Thank you. Any more? Okay, then that's it. Thank you very much, Valeria. And the next presenter is Ekaterina Stankova from Sechenov Institute of Evolutionary Physiology and Biochemistry of Russian Academy of Sciences, with colleagues from St. Petersburg State Pediatric Medical University. And the topic is oscillatory brain activity during selective word retrieval in healthy adults. The presentation is here. Ekaterina, you can start now.
Moment, please.
Oh, it has just disappeared.
Can you hear me now?
Yes, we can. And now we can see the presentation again. Yes, you can start, please.
Hello, everyone. The study aimed to detail oscillatory brain activity, which underpins selective word retrieval, and compare it to activity during simple word construction. To study simple word construction, 1 moment, we ask participants to make the words from 6-letter sets. And to study selective word retrieval, we asked subjects to find 3-letter noun that would end first 6-letter noun and start the second 6-letter word. For example, here you can see inscription, adv, then 3 dots in a brackets, and then man. If you put word ice into the brackets, you will have 2 words, advice and iceman, successively. We have calculated EEG spectral power during both task performing in 6 frequency bands, and then we compared it in 4 conditions: before and after the answer, in no answer trials, and in control series. In this slide, you can see EEG spectral power changes during simple word construction on the left and selective word retrieval on the right. We can conclude that pretty the same changes occurred during both task performing, such as the increasing of theta band power in frontal sides, decreasing of alpha band power in posterior sides, and the general effect of beta band power decreasing in almost all the leads. In addition, the increasing of relative theta power and theta beta ratio have been obtained. On the next step, we compared oscillatory brain activity, which provides simple word construction and selective word retrieval. We have not found any differences in control conditions and after the answer, but there were some differences in no answer and before the answer condition in posterior temporal sides mostly. And the beta band power in these leads were significantly higher in case participant had to use rule for word finding. Considering the role of posterior part of superior temporal gyros in control access to phonology, we suppose that efficiency of selective word retrieval in our task were limited by phonological representation activation more than by rule checking. That's all. Thank you.
Thank you very much. Questions, please?
If I can ask a question, if you can hear me, I have a bad connection.
Yes, we can hear you. Go ahead.
Thank you very much. What are your ideas about where exactly in the brain these beta modulations come from? So what structures contribute to them?
We consider that beta band have cortical sources, and this data we're proceeding that this data shows that there is some local activation in posterior temporal zones, cortical activation.
Yes, thank you.
Thank you very much. And I'm inviting the next presenter, Elena Reyehakainen from St. Petersburg State University, and your colleagues from Pavlov First St. Petersburg State Medical University, Russian words for speech audiometry in children.
Good afternoon, dear colleagues. Can you hear me?
Good afternoon. Yes, we can hear you. We can see you now.
Okay, then just a second. I will switch on my presentation. Can you see it?
Yes, we can. You can start now.
Yeah, just a second. I will switch on the full screen mode. It can take just a second. Yeah. Okay, our talk today is on speech audiometry in children, and speech audiometry and pure tone audiometry are fundamental tools in hearing loss assessment. Speech audiometry provides information on how people recognize words. It is possible in children from the age of 4 and sometimes even earlier. And one of the crucial requirements for speech audiometry in children is that all words in the word list should be familiar to them. Until now, when assessing hearing in Russian-speaking children, the lists of 2- and 3-syllable words created by Osherovich in 1965 were used, and we argue that using monosyllabic words should increase the accuracy of speech audiometry, as monosyllabic words have less information redundancy. Thus, today we introduce new monosyllabic word lists for Russian speech audiometry in children. To compile these lists, we selected frequent monosyllabic nouns from the new frequency dictionary of the modern Russian language by Lishevsky and Sharov, and the words were then compared with speech therapy word lists and teaching aids for children under the age of 7 years old. We also presented these words to 40 children without hearing impairments and asked them to explain the meaning of the words. And only the words that were familiar to at least 85% of children were included in the final word list. Then each list consisted of 10 words and contained as many different Russian phonemes as possible. And to perform speech audiometry with these lists, we recorded them read by a male speaker. We presented all lists to 30 children of 3 age groups with normal hearing under equivalent test conditions, as you may see on the slide. We calculated the percentage of correct answers given by each participant for each word list. Then we revised 7 word lists where the average percentage of correct answers was lower than 80%. We substituted 16 words from these lists that caused the greatest number of errors. We also moved some words from one list to another to maintain the balance of sounds in different lists and performed a new audio recording of the material. And now we have these 10 final lists, and each subsequent testing confirmed the perceptual balance of the new word lists, and the percentage of correct answers was higher than 92%. And these word lists are used in clinical practice now. And you can get further details about these lists and the list for speech audiometry in adults in our book that you can see on the slide. Thank you for your attention.
Thank you, Yelena. We already have one hand from Anastasia Lopukhina. Please go ahead.
Thank you. Yelena, thank you. It's a very interesting study. I'm curious, maybe I missed it. What was the task for the participants? So what was they were supposed to do?
In the first experiment, when we were just selecting the words, the appropriate words, we asked participants just to explain what the word means. As they were children, small children from 5 to 7 years old, we just asked, what is it? And we accept it as correct answers, actually any kind of explanation. It means they could provide any synonym, or they could just describe the situation, and it was okay. But then in the speech audiometry test, it's like general procedure when you ask, it was performed by my colleagues, by Maria Yurievna Baboshko, who is also here now, and it is like a normal speech audiometry procedure when you ask like participants to name the words.
To read them or just to repeat?
No, to listen to them. As it is a speech audiometry, they were listening to the words and they were naming them, the words, like repeating.
Repeating, right?
Repeating, yeah,
okay.
Yeah.
Why did you decide to choose real words and not pseudo words in this?
Yeah, it's a good question, but actually it's always a question, why not to use pseudo words or just some syllables, combinations of sounds without any meaning. But you know, we can discuss it later also, but it's always difficult for people with hearing loss to recognize like sounds. And so if we perform pseudo words or syllables, it makes it even more difficult. And we also want to know how well they recognize real speech. And in real life, they have to cope with the words, not with pseudo words. Yeah, and normally, as far as I know, in clinical practice, they undergo both pure tone audiometry and also like speech audiometry.
Thank you very much. I think it's time for us to proceed, and I'm inviting the next presenter, Natalia Nuzhina from Privolzhsky Research Medical University, with the presentation Neurophysiological Features of Brain Stages of Visual Verbal Information Processing in the Conditions of Target Mental Activity. We can see the screen now.
Good afternoon, dear organizing committee, dear attendees of our conference. The subject of my presentation is neurophysiological features of brain stages of visual verbal information processing in the conditions of target mental activity. The purpose of this study is to compare the event-related potentials received during the semantic categorization and passive reading of verbal information. What about method? 25 students of natural and scientific profile, aged from 19 to 25 years, were participants of our study. Combinations of an adjective and a noun were presented as a stimulus material. The subject's task was to categorize phrases by the first word, adjective, in the first series of presentations, and to categorize phrases by the second word, noun, in the second series by pressing a certain key. We analyzed the components of event-related potentials in response to the presentations of adjectives and nouns in target and non-target conditions. Our findings are presented on this slide. Target nouns versus non-target ones elicited larger amplitude of component with latency around 200 milliseconds after the stimulus onset, P200, in the central and parietal leads. And smaller amplitude of the negative wave with a latency around 400 milliseconds and 400 in the central and parietal leads. Also, we observed larger amplitude of the late negative wave in the central, parietal, and temporal parietal leads. Target adjectives versus non-target ones demonstrated larger amplitude of the late positive component around 600 milliseconds after stimulus onset in the parietal region. Figure 1 compares the ERPs in response to the target and non-target adjectives, the gray lines, and the ERPs in response to the target and non-target nouns, the black lines. So we can see that there is differences between target and non-target conditions for nouns, but not for adjectives, found for the P200 and N400 components. Also, we can observe pronounced differences for the late negative wave in response to the presentation of target and non-target nouns. So, to sum up, we can generally conclude that the ERPs in response to the nouns presentations were sensitive to target and non-target conditions, both in the early and the late stages, and the adjectives did not show high sensitivity to changes in these presentation conditions. Thank you for your attention.
Thank you, Natalie, for your presentation. Now we have time for questions. Let me see. Are there any?
See, Katerina wants to ask one.
I want to ask, have you any idea why this is happening? Okay.
Okay, we probably can come back to this topic during the short break after the session itself. Maybe there will be more.
So should
or I see that
there was a question.
It looks like Yuri Shterov has his microphone unmuted, so but nothing. I can hear nothing. Probably this is something on my side. Yuri,
I can take over
speaking,
then. Maybe I can take over. I think Ekaterina asked a question, and maybe Natalia, you can answer that.
Yes, thank you for your question. I can say about the components, and what about N400 component. Maybe the differences deals with the incongruity with the task, because non-target stimuli demonstrated increased amplitude of this component, and we know that the amplitude of the component N400 increase when the stimulus is not congruent to the context, and maybe the incongruity with the task influence to this amplitude. And what about the component about the late negative wave? It's very interesting, because this component usually interpreted as a reflection of changes in attention or memorizing. So it's very interesting question about the explaining the role of our component and 700, because the late negative wave. So maybe it could be a marker of the target processes in our brains, because the amplitude of this component was also increased for a target stimulus in our previous study. And what about differences between adjectives and nouns? Maybe it deals with the main role of the nouns in our speech, so there were so pronounced differences.
Can I ask you? You always had adjective first and noun second, or was it counterbalanced?
No, all time the adjective was first.
Yeah, so this might affect your ERP responses. They are just masked by another stimulus coming up. So if you could, in Russian, you could easily do that. You could counterbalance. You could switch for half the trials. You could switch positions. Rather than saying кожаный диван, you could say divan кожаный, and this would make it more.
It would be
physically, it would be physically more balanced. But I'm afraid I'm not sure if the chair is back online. But I think we need to continue.
I am, and yes, I apologize for some internet connection, which is pretty poor on my side. And thank you, Yuri, for helping me chairing the session. And the next presentation is by Alexandra Puchkova from Pushkin State Russian Language Institute, Word Length and Frequency Effects on Eye Movement Parameters in Elementary School Children Reading Textbooks. Yes, the presentation is on. You can start now. Alexandra, can you hear me?
Can you hear me?
Yes, now we can, but looks like the sound is not very clear.
Ongoing research on readability assessment for school textbooks. Comprehensibility and accessibility are key features when we are talking about learning to read and textbooks for younger children in particular. There are many readability formulas which aim to assess this comprehensibility and readability, but mainly they focus on word length, sentence length, and rarely on word frequency. So to objectively assess their usefulness and for textbooks, we need to broaden our research on frequency effects and word length effects on reading. Fixation parameters are a good general measure of reading difficulty. So we wanted to find if the text feature based on word length and frequency parameters are helpful for readability assessments for Russian educational texts aimed for primary school children. And how exactly do these parameters impact the eye movement in them? We have chosen 7 narrative and descriptive texts from real Russian textbooks for reading for grades 2 and 3. And we have asked our subjects, pupils, to read aloud as fast as they could, and then to ask a comprehension question to avoid mindless reading. We have used an ASR Research iLink 1000 eye tracking system, and 53 children took part from Moscow schools with no problem with reading and no other general problems took part in the study. As expected, reading speeds increased from grade to grade, and fixation length significantly dropped from grade 1 to grade 2 to grade 3. This was irregardless of particular text. In every text we had almost the same results. And of course, we also found the drop in a number of fixations per word, as we found the transfer from sublexical to lexical strategy. Number of fixations on a word was significantly influenced by both word length and frequency. We have separated all words into frequency and word and length ranks, and both were important for our subjects. Also, for average fixation length, both frequency and length were important, but when we standardized fixation data, to remove individual differences and pull all the data together, only word frequency effect remained, and word length effect was almost lost. So as expected, the overall reading speed grew, and but the difference between reading easy and moderate and hard text remained. And word frequency effect was the most important. So when we are talking about readability assessment and readability formulas, they should include word frequency. And what we have also noted, that we have used frequency data from Russian corpus, from Russian language corpus. And it doesn't really reflect the familiarity of children. So maybe some children's own subcorpus would be of use for these type of studies. Thank you very much.
Thank you. We can now allow maybe one short question. Yes, I can see the hand from Ekaterina Stankova and another one from Anastasia Lopukhina. Okay, let's try to fit both questions. I thought Ekaterina was the first one.
I have methodological questions. What dictionary did you use when you accessed frequency? Was it designed for children or for adults?
No, it was Russian language corpus. So it's very general. It includes all types of texts. And that's why I note that it may be viewed as limitation or a note of importance in our study.
Okay, thank you.
Thank you. And then another question from Anastasia Lopukhina.
Thank you. I just have a short question about the possible interpretation of this really novel result that length doesn't affect reading fluency. Well, it's unexpected, so how can you interpret it?
Yeah, I'm not saying that it doesn't impact, it generally impacts. The only parameter that was not affected by word length was standardized fixation, and it's measured not in milliseconds. Sorry, I see a typo here. It's well, it's quite a synthetic parameter, and we are also trying to understand why that is, because when we are measuring just usual fixation duration, of course we do get length effects.
Thank you. Okay, I think it's time for us to keep going. And I'm inviting Ulyana Kochetkova, St. Petersburg State University, and your presentation is Perception of Irony in Speech.
Good afternoon. My name is Ulyana Kochetkova, and while I'm sharing my screen, I would like to, is it good? Yeah, I would like to thank the organizing committee for this wonderful opportunity to present our work. Can you see the presentation? That's good?
Yes, everything works. Thank you.
So our main goal, as you can see from the title, is to understand whether the listeners are able to perceive irony in speech when there is no lexical, grammatical marker of it, and when the listeners don't hear any context. First of all, why should we study irony? We know that the correct distinction and reproduction of communicative types are very important, but the same applies to the irony, when only the intonation negates the lexical meaning. This type of irony is called antiphrasis, and that's the type we have focused on in our study. If we ignore such a negation, it may lead to the failure of the whole communication process, for example, in a human-machine dialogue systems. So how can we find the material for studying irony? At the first step of our analysis, we created a subcorpus of Russian ironic speech. We studied fiction, audiobooks, radio plays, films, series, talk shows, etc. Then, basing on this analysis, on the analysis of this material, we selected the most typical contexts and lexical markers, and we constructed short dialogues and monologues. Here is an example of a lexical marker, тоже мне, сам, you are. Then the lexical markers were omitted and target fragments. In this example, the target fragment is Sovetchik. They were inserted in various kinds of ironic and non-ironic utterances. And then we suggested obtain texts for reading to the native Russian speakers, 2 men and 2 women. Then we conducted an auditory perception experiment, and I must thank our student and member of our research group, Darina Vasilova, who made it great work. 45 target fragments without any context or marker of irony were extracted from the recordings. We randomized them and suggested to listeners to associate each fragment to one of the 4 written contexts. 2 experiments were done, one with male voices and another one with female voices. Then we saw that listeners can successfully detect irony in male speech relying only on acoustic cues with no additional lexical or grammatical information. Here's an example.
Он объяснит.
When we had the results of the second experiment, we were happy to see that in women's speech, listeners even better detected the irony. Here's another example. Then we produced acoustic analysis. It showed that the stress vowel in the ironic utterances was longer. The mean differences was about 55 milliseconds in male speech and 35 in female speech. And the mean intensity level of the phrase with irony was higher. The mean difference was about 8 decibels in male speech and 2 decibels in female speech. So we saw that listeners are able to recognize ironic utterances, relying only on phonetic characteristics. And also we saw that irony was better detected in female speech. Thank you for your attention.
Thank you very much. Very nice presentation and very interesting topic. Any questions, please? Yes, we have a question from Yulia Nenasheva. Go ahead.
So can you hear me?
Yes, we can.
That's good. So, thank you for a very interesting presentation. It was more so interesting for me because I also work with intonation, with prosody. The question is about, so you spoke about some significant differences that you found in prosodic components of phrases. Did those components concern the whole phrase or some particular element of the phrase? Like the beginning, the middle, or the end of the phrase? Mm-hmm. Or maybe the part where exactly the ironic item was located?
Thank you very much. It's a wonderful question. Actually, when we started to analyze and to make the acoustic analysis, we saw that sometimes it was focused in one part, the head, for instance, and another, or on the marker, when the marker was there. Sometimes it was repeated, the same melodic contour. And sometimes the target fragment was absolutely neutral. And the marker had this intonations, its special intonation contour. So that's the goal of our future work, actually, because the next step of our analysis will, now we enlarged our corpus, and we have about 50 speakers, even more. So it's a huge material, and we will analyze it, and we will see how it works statistically. You know, how often it appears in different parts. But that's the goal of the future work. Mm-hmm. Thank you.
Thank you. Maybe I will just give one very short commentary and not even a question, and we can discuss later. I just wonder whether you plan to include into this analysis some facial expressions, because it's very well described that not just intonation, but also these subtle markers like raising your eyebrow or something else, very, very tiny, is also a very strong indicator of the irony and helps the listener or any perceiver to detect this as an irony and not just plain speech. That would be interesting, probably.
Absolutely, that's what we are doing right now, because we have video camera and we are annotating gestures and mimics because it's different. And we also analyzed video films, and we are planning an experiment comparing the video without sound and the sound without video. So we right now we are doing that. So thank you very much. It's absolutely right.
Thank you very much. So we are waiting you next year with the new presentation on these results.
Thank you very much.
Thank you again. And we have to continue now. And the next presenter is Ivan Shkurko from St. Petersburg State University. Does sound determine synesthetic color? Evidence from Russian.
I think, yes. Okay. Good afternoon, dear colleagues. Grapheme color synesthesia. Grapheme color synesthesia is defined as a condition in which graphemes are colored in a certain way in a person's mind. There seem to be several factors that influence synesthesia, and sound seems to be one of them. The influence of sound was proven to be low in English, but more significant in Japanese and Korean. Our study's goal was to understand if sound plays a role in perception of Cyrillic graphemes in Russian. Synesthesia, to do this, we asked the participants to pass a test called Synesthesia Battery, which is aimed at verifying that a person actually experiences synesthesia. We then asked 15 participants who had successfully passed it to choose the colors that, in their opinion, correspond to certain two-letter combinations. In the first experiment, these included graphemes pronounced as either voiced or voiceless consonants, depending on their position. For example, these were combinations such as B, P, Ib, and Ip. And the idea here is that Ib and Ip would be pronounced the same. In the second experiment, these were also vowel plus consonant combinations that may be pronounced identically in Russian, such as Ish, Ish, and Shi, Shi. So Shi, Shi is also pronounced identically, and Ish, Ish is pronounced differently. And we hypothesized that the geometrical distance in the color space RGB between the chosen colors would be shorter when the pronunciation of these combinations is the same, like in case of Ish, Ish, Shi, Shi, than when it is different, like BP or Ish, Ish. As for results, we conducted an analysis of variance, which showed the influence of this sound in the first experiment with p-value of 0.5%. The influence of the variable participant was also found in both experiments, with a p-value lower than 0.1%. We then used the students' t-test to compare every participant's color values for separate letter combinations. The sound turned out to be significant for some participants of the first experiment and for other participants of the second experiment. And these results suggest that sound actually can influence the choice of color in synesthesia in Russian-speaking synesthetes. It also seems to be more significant for consonants than for vowels, this effect. And as the sound played a role for some participants in the first experiment and for others in the second, it can also be assumed that the influence of sound is selective, meaning that it emerges on different grapheme combinations for different participants. Thank you for your attention.
Thank you very much. Perfect timing. And any questions, please?
Can I ask a quick one?
Yes, please, Yuri.
So when you say it was significant for some participants, but not for others, what exactly do you mean? Was it always a within subject statistics?
I think so.
So how sort of consistent are these results? Could these just be spurious effects that, you know, sometimes show up and sometimes they don't? So can you find any pattern there that would be sort of consistent across people?
It actually could be, and we didn't look that deep into it, so it's not possible to say that. It certainly is selective, but right. Yes.
Yes. No, and another comment is it's interesting indeed if it has different roles for different sounds, such as vowels and consonants. I think numbers also have strong synesthetic associations, and they are not directly associated with sounds in the same way. There could be something else to study.
Mm-hmm. Yes, thank you for this observation.
Thank you very much, Ivan. And I'm about to announce the last flash presentation for today, since Viktor Karpachev canceled his presentation. So now we're going to listen to, I think the presenter and author is Alexei Korneev, if I'm not wrong. And the topic is the neuropsychological assessment of verbal memory in preschoolers and primary school children.
Yes, hello, can you hear me?
Hello, yes, we can hear you and we can see you.
Yeah. Okay, just a moment. Turn on my screen. So you can see?
Yes.
Yeah. Okay. Hello, everybody. I'd like to present the results of study of verbal memory in early school children. And in the study, we tried to find some associations between verbal task performance and states of different other cognitive functions. So in traditional neuropsychological assessment, we routinely use the following procedure to assess the state of verbal memory in children. We present to a child two groups of 3 words: холод, рама, клин, cold frame, wedge, and гость, риск, дождь, guest, risk, rain, and asked him or her to repeat these words. The words are presented 3 times, and after each repetition, the subject is asked to repeat the words. After an interfering task, he is asked again to recall the words without presentation. So we have 4 reproductions of words, and now I'll present our attempt to differentiate neuropsychological characteristics of children based on the analysis of the combination of productivity in first 3 reproductions. Productivity was assessed by the number of correct words in each repetition. In a total, 370 children of different ages participated in the study, from preschoolers to 3rd graders, and you can see on the slide the sample sizes. Besides the verbal memory task, children passed through full neuropsychological assessment, and it included analysis of executive functions, cerebromotor organization functions, functions of processing of information in different modalities, functions of regulation of activation, first block of the brain in terms of Luria, left hemisphere and right hemisphere functions. So based on the distribution of productivity in the first 3 reproductions, we distinguished 6 groups of children with different profiles of productivity. First were children with high productivity. The second group is children with a sharp increase in productivity from first to second trial. Third group is children with decrease in productivity compared to previous trials from first to second or from second to third repetition. Children with not high flat productivity. Next, 5th group is children with reduced productivity, and finally children with low productivity. The size of these groups you can see on the slide. Next, we analyzed the neuropsychological profiles of children from these 6 groups. In children 1, the indices of all functions were above average. It's a high normative group. In the second group, children had similar indices with exception of the right hemisphere function index, which are rather bad, rather high. In third group, with decrease of productivity, children had the worst index of auditory information processing. In fourth group, with flat productivity, children demonstrated a low state of functions of the first or energetic block of the brain. In children from 5 groups, we found the low state of all functions. Sorry, just a moment. Yes, all functions except serial order functions and processing of kinesthetic information. And finally, the children in the 6th group with low productivity, all functions were rather low. And so we conclude that results of our study support the idea that many mental components are involved in the memory, in the process of verbal memorization, and it demands the further studies, and we are going to conduct it in future. So thank you for attention. Any questions?
Thank you very much. Yes, we can have some questions.
As it's become traditional, can I ask one?
Yes, please.
So what were the, thank you very much. What were the criteria for separating the groups? Particularly, like you had groups with reduced productivity and with low productivity. How is that different? And I suppose they were also flat, so flat low and flat reduced, or so
yes,
how is this? Is this too many, perhaps?
Well, we distinguished these groups because they had in an average different level of productivity, and we tried to look at in detail what is the lowest clear bad group with really low productivity.
Did you apply something like, I don't know, a sigma node distribution, and then looking at 1-2 sigmas from the medium, or the median?
Yes, okay, I see. We analyzed the absolute values of productivity, and we saw some different groups. And also we tried to conduct a cluster analysis to these groups, and the results were similar.
Right, thank you.
Mm-hmm.
Thank you. Any more questions? Yes, we have one from Ekaterina Stankova.
I have a question. What was a point to present those words not at the same time, all of them, but sequentially, 3, then another 3?
Because a child in this age maybe cannot remember the sequence that consists of 6 words, but 3 is more
ecological.
More ecological, yes, and the real task for your child.
Okay.
Mm-hmm.
Thank you. Any more? Thank you once again, Alexei.
Thank you.
Very interesting. And I think we can allow some space and some time for a general discussion. If anyone would like to give any commentary on any flash presentation that we heard today, please feel free to. Otherwise, we can continue with our short break before our closing keynote lecture.
Perhaps if there are any questions for the preceding slide sessions that people wanted to ask.
There might be some.
Or comments.
I remember there was probably 1 or maybe 2 questions for the presentation of Alexander Kornev.
If he's still with us, I had a brief question. If I could.
I think that.
Are you with us? I can see him on.
Well, the account is here.
Yeah, the account is. All right, then I can. Yeah. Yes. Okay.
Yeah.
Yes. Hello. Yes. With respect to your presentation, Alexander Nikolaevich, I had a question. It's like sort of a chicken and egg question. So you made a point of high order and low order deficits. So could this be that one is still driven by the other? It's that which one is the chicken, which one's the egg, or do you think these are independent?
You mean that maybe a low-level process may be induced high-level difficulty?
Yeah, exactly. Yeah, so the low level of difficulties just cannot, stop people from performing highly and at more complex levels.
I don't think so, because if it will be so, if it will be true, all dyslexics have to have the same level, same limitations in comprehension, because all of them have low level process deficiency. But in our group, the level of comprehension was not the same. Some of participants have very strong limitations. They can understand only about 1/3 of all the content, and another one rather near to norm. So we didn't find correlations between fluency and comprehension. If these two levels, high and low, related each other, we shall find a correlation between, for example, fluency, reading speed, and comprehension level. On one hand, but on the other hand, there are multiple publications about executive functions deficiency in dyslexics, reasoning difficulties, and it is, I suppose, rather natural to expect some limitations in not scanning the text. I want to highlight this point. The reading, it is not only collection of information. Every reader have to construct their own text base, their own net of macro proposition. This is rather creative work, and it is naturally that some of dyslexics with such cluster of different comorbid limitations, syndromes, have some limited comprehension ability.
Right. Thank you very much. Thank you very much.
Thank you very much. Any more commentaries or questions that we didn't manage to ask during the main time?
Maybe we could have a...
Well, I think, yes, probably it's time to have some rest now. We start the next session, which is a keynote lecture and the closing lecture for this year conference at 4:30 Moscow time. And the keynote speaker is Dr. Olga Dragoy from Harris School of Economics. And the topic of her talk is language pathways, the role of white matter tracts in language processing. She is going to present some unique and unpublished data, so don't miss it. And we're gonna wait you to be back at 4:30. Enjoy the break then.
Right. Thank you. See you in 35 minutes. Thanks to all the presenters again.
Olga, hello, Olga Dragoy. If you want, we could check your presentation. Did you hear me?
Yes, I can hear you. Hello.
Hello.
Just wait a second. Are you making me a co-host?
I think you could do it without this, but I could.
Okay, I'll try. Oops. Yeah.
Do you have any multimedia audio files in your presentation?
Not the audio files. I have some video presentations, but as far as I understand, they should work as they are. Can you see my entire screen?
Yes, yes.
Okay, great. Then, so I'm ready to go, and we're starting in like 7 minutes, right?
Yes, yes.
Perfect. Perfect.
Okay, time for rest. Thank you.
Yeah, thanks.
Hello, Olga is here already. I think we're going to start in 1 minute.
Yeah, I'm going to share my screen one more time.
It works.
Shall we start, or shall we give it a couple of minutes? People are starting to come back.
Yes, probably just a couple of minutes, and
I mean, it's not more than that.
I think there is no point to delay
Last.
further.
The last leg.
I won't make you busy for 1.5 hours anyway.
All right. Let's see. Let's see. It's,
Right.
This is an interesting format, I have to say. This has been 2 interesting days of experiencing this online conferencing, and it's, yeah, you can see advantages, but also the interactivity is actually missing, I think, to a large extent, when people are hiding behind avatars and muted microphones. So is this a new Pokrovka campus on your background?
Right. I guess you prefer to see that rather than my kid's bedroom on the background.
Right. No, of course. I believe you at work, of course. Sometimes you see people with the same background and you wonder how they end up being in the same chair, one of these default Skype backgrounds. Maybe we should start slowly, and I'm sure a few more people will connect here and on YouTube channel as we go. So I'd like to start by thanking everybody for staying with us until the end. And my special thanks go to Dr. Olga Dragoy, who has kindly agreed to give a keynote presentation at this conference. And I'd like to say a few words about our speaker. Olga, I think originally is a linguist or a philologist in Russian terms, with a background in theoretical linguistics and later in clinical linguistics, having done basic education, receiving a master degree at Potsdam, followed by a PhD or a candidate degree back at home. Dr. Dragoy on Literature Horizon was focused on aphasia, aphasiology, and specific deficits that aphasic people exhibit in terms of syntax and other properties. But what strikes me first about Olga is genuine keen interest to different sides of the language function. And we discussed so many different things and thought of so many different projects. And you've moved to other areas, not just the physiology, but also other areas, connectivity. This is something we are going to hear more about today. And Olga is a very successful, so to speak, young senior scientist. We're heading a big and successful center for language and brain at Higher School of Economics. And today she will speak to us about language pathways and white matter tracks in language processing. Thank you very much, Olga, and please, the floor is yours.
Thank you very much, Yuri, for such flattering introduction. I'm very happy that I finally managed to join you, at least in this online format. I really hope that this year I would be able to come to St. Petersburg to meet all of you in person, but yeah, other forces interfered with my willings. I'm pleased and happy to share with you today my thoughts and kind of summary about the contemporary state of language anatomical models, and as well as to share with you the recent findings coming from our own center. And as the title states, I will talk today on language white matter, about white matter pathways supporting language as a higher cognitive function. And I would like to start right away from the focus of my own view and the contemporary common view on language, which is considered as a network-based function. And of course, I would like to mention the classic anatomy of language, and not to show that broken Wernicke are dead, but to probably revive the forgotten notions the classics introduced. So as most of you know, the classic anatomy of language includes several central notions, anatomical notions, as the Broca and the Wernicke areas, and the link, the anatomical connection between them, which is the acute fasciculus. And as the history goes, in the most of these findings were announced and published in the second half of the 19th century, although there is, some of you know that there is some debate about the Broca's area and the debate between Paul Broca and Mark Dux, who stated that, whose son stated that his father described the Broca area and its major features 30 years before Paul Broca. But Paul Broca is a renowned figure whose name is in this area, and who is always remembered in relations to the motive aspect of language. So with his name, the posterior third of the inferior frontal gyrus is related to the seat of the ability to articulate language. And already at this point, I would like to make it very clear that Paul Broca talked about articulation, not about syntactic abilities as we do nowadays. So literally, he described this type of aphasia, which was further named with his name, as the loss not of the memory of the words, nor the action of the nerves, meaning that the deficit is neither the core linguistic, for example, syntactic, nor peripheral. It is a particular faculty to articulate language, which is lost, he said. So no articulation was possible in his famous patients. So a decade later, Carl Wernicke described the posterior part of the superior temporal gyrus as the seat of auditory word images. And he was his probably the second important contribution to the language model at that time was that he clearly described the link, the anatomical white matter link between the Wernicke and the Broca area, which is the acute fasciculus. And a little bit later, Ludwig Lichtheim summarized these findings and clearly articulated a revolutionary at that time integral model of neuroanatomical pathways supporting language, communication, and as communication among brain regions. And that was very important because that was basically the first language-related clear articulation of functional specialization. Later on, this model is known as, in different versions, as Broca-Wernicke-Lichtheim or Broca-Wernicke-Lichtheim-Geschwind model. Geschwind joined this company a little bit later, a century later, in fact, and summarized it again, put new life into the model, made it very wide known and common, but simplified it. And a lot of very important nodes of classics were forgotten at this point. So the classic anatomy of language, as Geschwind described it in 1979, was characterized by limited spatial precision. So the even Broca and Wernicke areas were described not very clearly. But the model also was characterized by high functional modularity. So it was clearly stated that only those specifically mentioned areas are relevant for language and the link between them. This model, this form of model suffers from a few very important drawbacks. First of all, it doesn't account at all for language complexity. As the linguists who are present here and also the psychologists and other people from other specialties who deal with language, of course, know that language is a multi-layer phenomenon. So this model took language as language in general. It didn't differentiate between layers of language, that is phonological, lexical, syntactic, discourse, very important layer. This is the way how we actually communicate. And the findings from the recent decades clearly indicate that broken Wernicke aphasias do not occur necessarily after the damage to those lesions. This is greatly summarized in the paper by Nina Dronkers in 2007. So basically, if a patient gets a stroke into her Broca area, she may get or not the Broca aphasia. And on the other hand, another patient with a damage outside Broca area can get the Broca aphasia. And at this point, I would like to get back to original writings, the classics. For example, Ludwig Lichtheim wrote, oops, can you hear me?
Yes, everything works.
Can you hear me well?
Yes, pretty well.
Well, can anybody respond to me?
Yes, we can hear you well.
Anna, tell me if you can hear me.
I can hear you, yes.
Great, because my earphone connection was lost for some reason. Okay.
We can hear you well.
Okay, great. So I go on. So Ludwig Lichtheim wrote, I do not consider the function to be localized in one spot of the brain. Seems very familiar to us now, but rather to result from the combined action of the whole sensorial sphere. So the classics who proposed this model already stated that it is not modular. On the other hand, Wernicke wrote that everything which goes beyond elementary physical functions is an achievement of the fiber tracts, which connect the different regions of the cortex to each other. So this is one of the first and very clear indications about the role of white matter tracts in the language system. So it's the model of language shouldn't be limited to cortical regions only. And here we switch to the modern state of the art. There are different contemporary models of language. And there is one, I would say, a family of models, which is summarized in this slide. It is inspired by models of visual processing and is referred as dual stream model of language. So similarly to visual processing, in this model, the what stream and the how stream are stated, and in the visual domain, the what stream supports feature and object recognition, and the how stream supports spatial localization for movement coordination. And this metaphor and this philosophy is brought to the language domain. And the dorsal stream, which is here in red, is stated to support sensory motor integration, and is stated to be involved and supporting language production, first of all. And the ventral stream, which is here in blue, is proposed to support speech comprehension. And yeah, there is a number of papers describing this model. So this is a more detailed scheme of the dual stream model of language. And you can see here the dorsal stream connecting the inferior parietal areas and the posterior temporal areas with the posterior frontal regions, both inferior and superior. And the dorsal stream is considered to be more lateralized in the language dominant hemisphere, which is left in most of people. And the ventral stream is more bilaterally organized and includes acoustic processing, phonological processing, lexical retrieval, and semantic processing. And the ventral stream is also stated to be connected ventrally to the posterior inferior frontal gyrus. And yes, this is what I mentioned. So in the ventral stream, the authors included the following processing stages. So the superior temporal gyrus supports phonological processing, so acoustic and phonology, and the middle temporal gyrus and actually inferior temporal gyrus supports lexical access. And the temporal pole is responsible for integration of semantic information. And you can see that this is these stages clearly reflect the comprehension aspect of language. So we hear some acoustic signal, we access words, we process semantics. And the dorsal stream, which is more left hemisphere lateralized, includes sensory motor integration, and we'll discuss that a little bit in details further, which basically takes place in the angular gyrus. And then the information goes to the inferior frontal gyrus, the insular cortex, which is hidden here in between the frontal and temporal lobes, and premotor cortex. And which supports articulation for language. Right. And just to mention that both pathways are stated to interact with the distributed semantic network. I won't go in details regarding this, but it is related to the notion of distributed semantics, which basically is linked to our sensorimotor behavior and experience. There is basically vast evidence in favor of this dual stream philosophy and dual stream model of language. And just to mention, there is a recent meta-analysis of 11,000 fMRI experiments, and where the authors show language-specific components for the purely auditory task. And you can see here that this task highlights and causes the activation primarily in the temporal cortex bilaterally, clearly bilaterally, and equally bilaterally. Speech production induces activation in the superior temporal gyrus and posterior frontal lobe, both inferiorly and more superiorly. And it is bilateral, but we can see more activation in the left hemisphere. And the comprehension, which is a complex, actually language comprehension, is a little bit more complex in terms of linguistic components than just audition, because it entails both listening, lexical access, comprehension of syntactic constructions, and also activates some frontal areas because of syntactic processing, because of sensorimotor integration, and different kinds of motor stereotypes that can be induced by the semantics of what we comprehend. But the dual stream, the family of dual stream models of language are not specific at all in terms of actual anatomical pathways conveying this information and supporting the interaction between these cortical regions which are in the model. And but other people thought about that. And here we go to the associative white matter tracts of the brain, which are just one category of white matter pathways existing in the brain. They connect cortical areas and also subcortical gray matter nuclei within one hemisphere. Which means, but we do not include corpus callosum here, for example. They provide long distance associations, meaning that they connect different lobes primarily. Of course, every gyrus is connected to the next one, and these are so-called U-shaped fibers. They are not associative white matter tracts. And this kind of white matter tracts are now considered as central elements in contemporary models of different, in fact, high cortical functions, including language. And this is what we're going to discuss today. So getting closer to language pathways, which you basically saw in this slide. So what I'm going to overview today is the arcuate fasciculus, which is already familiar to you, providing sensorimotor integration and in particular phonological processing. It is here in red with its 3 segments. The frontal Aslan tract, which is here in purple, supporting speech initiative and spontaneity. The inferior frontal occipital tract in purple, supporting semantic processing. And another system of ventral associative white matter tracts, the inferior longitudinal fasciculus in orange, which is more involved in lexical interface, and the uncinate fasciculus, which is which function is still difficult to tell for the moment, but it is believed to be involved to some aspects of semantic processing. So the acute fasciculus, and you can see already here that it's multicolored, and here is how we depict it. This is a convention. So historically, as I mentioned already, the acute fasciculus is a central language pathway. And it has three major areas of termination, which are the posterior inferior frontal cortex, the inferior parietal cortex, and the posterior superior temporal cortex. Please pay attention that that's already much more than just broken Wernicke areas. In particular, you can see here that two segments of the acute fasciculus considerably terminate in the so-called Geschwind area, which is in superior temporal, inferior parietal. As I already introduced, one of the commonly accepted model states that the acute fasciculus has three major segments: the long, the direct segment, which is here in red, and you can see it here, with the terminations in the posterior, primarily inferior frontal gyrus, but also some authors state that it terminates in the posterior middle temporal gyrus. And the temporal terminations include primarily posterior middle and inferior temporal gyrus. And again, please pay attention that this is not the classic Wernicke area. The Wernicke area is here in the superior temporal gyrus. And in my lab, we do a lot of tractography reconstructions, and very rarely we see the terminations of the acute fasciculus in the superior temporal gyrus. And the model also includes two other short indirect segments of the acute fasciculus: the anterior one, which is here in green, connecting the Broca territory, the posterior inferior frontal gyrus, and the Geschwind area, which I already mentioned. And the second indirect segment is the posterior one, connecting the same area where the long segment terminates and the posterior part of the Geschwind territory. And here, how they come together. Already here, I would like to mention that this anatomy of the most studied language pathway, the acute fasciculus, is still an open question. We have questions about both prefrontal, about frontal and temporal terminations of the acute fasciculus. For example, for a decade, tractography was done with the so-called DTI, diffusion tensor reconstructions. And it has some drawbacks. And now we switch to more advanced modeling of tractography. For example, here I present the spherical, constrained spherical deconvolution model of the same long segment of the acute fasciculus, and this is the same subject, and this is the same data acquired in the same scanner. Just we use two different approaches to tractography to reconstruct this long segment, which results in quite different reconstructions, as you can see. So there is a question, an open question about the existence of this prefrontal, which you can see, as you can see, really go terminations of the acute fasciculus, which really go to the orbital cortex. And also there were questions about the temporal terminations of the arcuate fasciculus. For example, here you can see the that was 10 years ago already, and still we do not know where exactly it terminates. So here is the probability of temporal terminations of the AF. As you can see, it can terminate very close to the, even to the temporal pole. To find out, in an attempt to find out the real anatomy of the arcuate fasciculus, we go for ex vivo dissections, and actually already nearly a century ago, the famous dissector Klinger showed, and this is just a picture from his book, 1935, showed how far to the prefrontal cortex the arcuate fasciculus goes. And here you can see the modern dissection from my Argentinian friend neurosurgeon. Here's the arcuate fasciculus with his several terminations in the premotor cortex, in the inferior frontal cortex, and also with prefrontal termination. So you can see that the anatomy is much more than we still consider. And I would like also to mention that in my lab, we do this kind of dissections, and we try to contribute to the anatomy of the arcuate fasciculus and hear how it goes. So basically we do manual dissections and then scan it. And then our, in an effort to make a 3D anatomy atlas in the end. So here, this is my own reconstruction. And here's the arcuate. This is the Geschwind territory. You can see the anterior segment coming here, the posterior, the long segment is below, and it extends to the prefrontal regions as well. Yeah, you need some experience to see that. So a few words about the development of the arcuate fasciculus. And it is closely related to the language development, as you will see, as you see in this slide. So in newborns, only the pathway connecting the temporal regions, here's the newborn, the temporal region with the premotor, not the Broca area, not the inferior frontal gyrus yet, just premotor areas. So only this pathway is myelinated when you're born. And this is related to the Babylon period and the known early learning of rule-based dependencies from auditory input. So I would say that this part of the arcuate fasciculus is the obligatory substrate, which is necessary for early language development, which is sensory motor integration in essence. So you hear something, you try to repeat, right? And you derive auditory rules from your auditory input. And so and the blue connection with which you can see here and which is present in adults is not even fully myelinated by 7 years old. It is there already, but it's not fully developed. And so there are two sources of evidence suggesting that this blue part of the arcuate fasciculus is constitutes and supports the fully fledged language, which we practice now, for example. On one hand, it is shown that adults accurately process syntactically complex sentences and activate this part, the Broca area, and the posterior portion of the superior temporal gyrus and sulcus during this syntactic processing. And on the other hand, children under the age of 7 do not process always correctly complex sentences, and this part of the arcuate fasciculus, as I mentioned, is not fully myelinated yet. Right. There is an interesting aspect of the acute fasciculus, which is its lateralization. So we'll we'll focus now on the long segment of the acute fasciculus. So there is the overall prevalence of asymmetric distribution of the direct segment of the AF. So it's in most people, it's strongly lateralized. And this is the seminal paper by Marco Catani, who was the first showing what kind of distribution there is in a human population regarding lateralization of the long segment of the acute. So 62.5% of his group had the long segment of the acute fasciculus only in the left hemisphere. Now we know that 13 years later that this result is partially a drawback of the DTI reconstructions they used at that time. So now when we do, in my lab, we've done like hundreds of reconstructions. And it is very rare when we do not see the right long segment of the acute fasciculus, even in clinical population. So this picture basically means that there is strong left lateralization in most of the people, but it doesn't mean that there is nothing here in the long segment on the right. It just means that it's very thin and some tractography model doesn't allow to reconstruct it. So then there are two nearly equal groups with the bilateral but still left lateralized long segment and a symmetrical bilateral representation of it. This study was done in 40 right-handed individuals. Later on, basically the same result was got in people with both right-handed preference and with atypical handedness, ambidextrous or left-handed. And you can see here that it constitutes, this is the absolute numbers. So but basically this is 81% of right-handed, and the same number of people with atypical handedness still have strong left lateralization of the long segment of the acute. And importantly, it has been shown that there is a significant correlation of the lateralization of the acute fasciculus, the long segment, with language performance. For example, the same study showed that higher left lateralization of the acute fasciculus correlates with better vocabulary and complex ideation performance. Complex ideation is a subtest of a diagnostic test. This is basically a comprehension of complex sentences. In atypical handed people, and it is correlated with better semantic fluency in right-handed people. So this cohort is healthy people, but still language performance is variable in healthy people as well as in the clinical population, not that drastically, but still. The lateralization of the acute fasciculus predicts the language performance. The clinical data sheds some more light on functional specificity of the acute fasciculus. So the story started with the acknowledgement of a general contribution of the acute fasciculus for language, like again, language in general, to different aspects of language. For example, in this study, it has been shown that it is the acute fasciculus lesion load. These are stroke patients. The acute fasciculus lesion load size significantly predicts rate informativeness and overall efficiency of speech as well as naming abilities. So all kinds of language aspect measured in this study. You can see it clearly here. So this is the AF lesion load. So 100% means 100 of acute fasciculus lesioned. And here you can see the words per minute and information units per minute, produced per minute. Both metrics are reduced the more the larger acute fasciculus is lesioned. On the other hand, here's going more to the specificity of the acute fasciculus. It has been shown that it is the AF focal lesions, so lesions exactly to the acute fasciculus, correlate with selective difficulties in repeating heard words, but do not correlate with word comprehension, picture naming, and verbal fluency. This behavioral linguistic pattern is representative for the conduction of aphasia. And here you can see where exactly the lesion was in this cohort of patients. In the same vein, in this study, they showed that damage to the acute fasciculus specifically causes impairment at the phonological level in different tasks. But as soon as phonology was involved, the language performance was reduced. So this data highlights the importance of the acute fasciculus for the non-semantic integration of auditory and motor speech processing, which constitutes the sensory-motor integration, which I have already mentioned. Similar support and similar data comes from intraoperative language mapping with direct electrical stimulation. And in this study, in this recent study by Johanna Sierpowska, our close colleague, it has been beautifully shown that the non-word repetition task is very sensitive, is basically the most sensitive task for during the acute fasciculus stimulation. It was compared with the word repetition task and with picture naming. And you can see here what went on during the operation when the neurosurgeon stimulated the acute fasciculus and the linguistic tested a patient with the non-word repetition task, with the word repetition task, and with picture naming. So here in black, you can see that this task was related to the most numerous errors. And at the post-operative stage, the non-word repetition was heavily impaired, and it was more impaired than other aspects of language. And here you can see in two patients, for example, in which the non-word repetition task didn't work well. And in picture naming, the phonological paraphasias were induced, which is like another side of phonological processing in production. These two patients got severe deficit in non-word repetition after the operation. In addition to the same idea that the acute fasciculus supports sensory-motor integration and phonological processing in particular, this study strongly suggests that non-word repetition is exactly the task that should be used for intraoperative acute fasciculus mapping. What about the right acute fasciculus? Do we need it at all? We do. That's the current answer. There is a very, very interesting study published 6 years ago about the role of the right long segment of the acute fasciculus in post-stroke aphasia severity. You can see here in the graph the volume of the long segment of the right arcuate fasciculus, and the aphasia quotidian, reflecting the overall aphasia severity in this cohort of patients. So the more the volume of the right arcuate fasciculus is, the less severe aphasia is. And here you can see 3 representative patients with very non-representative, arcuate fasciculus in the right hemisphere, and which is here on the aphasia quotidian scale. This patient has larger arcuate fasciculus and it behaves much better. And this patient with the very thick long segment of the AF in the right hemisphere had no aphasia at all. So this data highlights functional relevance of the right arcuate fasciculus, either for language in general, because we don't know if this is the result of the reorganization or stroke reorganization, or the initial state of the pathways in this particular individual, or it might reflect the genuine post-stroke reorganization. Okay. So the next white matter pathway, which is important for language and which is a focus of my own research, is the frontal Aslan tract. So this is the long-ranged tract present in the frontal lobe. So it doesn't connect different lobes. It connects distant regions within the frontal lobe. And it has terminations in the posterior inferior frontal gyrus and inferiorly, and supplementary motor area or pre-supplementary motor area superiorly in the superior frontal gyrus. It is identified both in post-mortem dissections and with diffusion tensor imaging. So there is no question that it exists. It is bilateral, and some authors state, like Marco Catani 8 years ago stated that it has left hemisphere dominance, but this is still an open question. We don't see in our data that it is lateralized. It's still a debate going on. So thinking about the function of the frontal Aslan tract, we should get back to the to its anatomy, because the anatomy itself suggests its functional contribution. So it connects the SMA supplementary motor area, which is widely known for supporting behavioral planning and executive control, with posterior inferior frontal gyrus. I don't have to mention its role in language production. So the FAT, the frontal Aslan tract, is a direct connection between them. So one might think, and in fact people thought that, that a frontal Aslan tract is a path allowing communication between general initiative and control, executive control, and language. And in fact, this idea was supported by some clinical data. For example, the fat damage correlated with a reduced verbal fluency in patients with brain damage of different etiology, in stroke, tumor, and primary progressive aphasia patients. And there was no, before we did that, in the end, there was no the direct evidence for the causal role of the frontal Aslan tract for this aspect of language. The intraoperative direct electrical stimulation studies showed non-specific contribution of the frontal Aslan tract for language. For example, in these studies, the authors mostly used object naming and got different kinds of like non-specific, not very revealing language errors like speech arrest, delayed speech, perseverations, all variety of language errors one can get during electrical stimulation of the brain. So in sum, the previous studies confirmed a language relevance of the left FAT, but didn't show its functional specificity for speech initiation, spontaneity, and fluency, as it was predicted theoretically. So we decided to test that carefully, and thought that sentence completion could be a very good task to tap into the function of the frontal assistant tract for the following reasons. So when you comprehend the beginning of the sentence, the context, and have to complete the sentence with a word or two, you do active syntactic sequences and context-relevant lexical search. And this is like a true initiation of real propositional language. It is not the fully fledged language as I do now, but kind of a spontaneous language in miniature. From physiology, we know that it is exactly the inability to build a complete sentence, which is a core symptom of the so-called dynamic aphasia related to the frontal lobe damage. So we contrasted the sentence completion task with the action naming, like picture naming with depicted actions. And we had 12 neurosurgery cases with the pathology adjacent to the frontal assistant tract, which we checked on their individual tractography reconstructions. So the tasks were the following. For the action naming, like the standard linguistic intraoperative task, a patient had to say here what the hero is doing in a picture. Here sings, здесь поет in Russian, in one word. And in the sentence completion task, a patient had to read aloud the two words presented in the screen and complete with one word. Свинка жует траву, for example. And for those of you who are not aware with the intraoperative functional mapping procedure, this is a brief overview. So we usually following the 3A procedure, asleep, awake, asleep. When first for the access, the patient is completely sedated. And then she is awakened, and we do the neurosurgeon does direct electrical stimulation, usually with a bipolar stimulator, and a linguist does functional testing, linguistic testing. And every time the stimulation occurs with a linguistic error, we mark this piece of the brain with a marker, and then the neurosurgeon tries to not to resect it. That's not our business anymore. So this is how we considered the awake setup in theory. Before we did that, this is how it is in real life. And coming back to our study of the frontal assistant tract, here you can see the mapping results of our 12 patients. And here are those markers I mentioned. And so based on intraoperative photography or navigation, we identified those sites on MRI, preoperative MRI of individual patients. We found that in most positive sites, when a patient made errors in a linguistic task, there was a task dissociation. So a patient could name an action based on a picture, but couldn't complete the presented sentence. Could read the beginning of the word of the sentence, but couldn't come up with the final word. And here you can see the distribution of the positive sites for both tasks. So the green sides are those specifically responsive for sentence completion here. And the blue sides, which are quite rare, are specifically responsive for verb generation, action picture naming, and the orange sides were those where the patient couldn't do both tasks. Since we had preoperative tractography for all of the patients, we overlaid the found positive sides on tractography reconstructions. And here what we found. All these sides specifically responsive for sentence completion were exactly on or in very close vicinity to the frontal Aslan tract. And you can see here, the frontal Aslan tract is in purple. You can see the variability of its anatomy in each individual patient. Of course, this is driven by pathology because these are mostly tumor patients, and the tumor can shift the tract to whatever side, to the front or to the back. And the frontal Aslan tract with the classic anatomy between the IFG and the SMA, pre-SMA, may end up in the motor cortex or in very frontally in the prefrontal cortex. But every time the positive sites, specifically responsive for sentence completion, were exactly on the frontal Aslan tract. And the second interesting finding in this study was what happened with this patient after the operation. As I mentioned, we just identified the positive linguistic positive sides, and then this is a medical business whether to resect it or not. And anyway, all those operations were done very close to the white matter tracts, and in some cases it was traumatized. So some patients, namely half of them, got some deterioration of some aspects of language, and when they got it, that was every time the discourse level, the level of spontaneous speech. And most of the patients recovered 3-6 months after the operation. And this raises another very interesting question about functional reorganization. So if we destroy or somehow damage partially the left frontal Aslan tract, still most of the patients recover. So what happens? Does the right frontal Aslan tract take over, or there are some other processes going on ipsilaterally? We still don't know. Right. So for the sake of the time, I will move further to the ventral language pathways, which are inferior frontal occipital fasciculus here, the inferior longitudinal fasciculus, and the uncinate. And some years back, actually the father of the still living father of awake craniotomies, the French neurosurgeon Hugh Dufour, proposed that these three tracts constitute two semantic pathways for language: the direct with the inferior frontal occipital, and the indirect, because there is a switch here in the temporal pole, with the inferior longitudinal and the uncinate fasciculus. So let's consider their specific functions. So the inferior frontal occipital fasciculus connects the occipital cortex and the frontal or the orbitofrontal cortex. It is, as basically all associative tracts, it is represented bilaterally, and as far as I know, there is no statement at the moment that it is left or right lateralized. And the electrical stimulation during awake craniotomies induces semantic paraphasias, meaning that instead of one word like cat, a patient produces another word, either semantically related or closely semantically related or distantly. So it can be dog or, I don't know, sofa. Its damage due to a stroke or neurosurgical resection leads to the impairment of semantic processing. And it is expressed both in comprehension and production. So this is why this pathway is proposed as the semantic pathway for language in general. The indirect semantic pathway proposed by Hugh Dufour includes the inferior longitudinal fasciculus and the ansonant fasciculus. And the ILAF has basically the same terminations in the occipital pole as the IFOF. It goes to the temporal pole, to the place from where the ansonant fasciculus originate. So the temporal pole is considered as a switch point between the ILAF and the ansonant fasciculus. Both tracts are represented bilaterally too as the IFOF, although for the ILAF there is an open debate whether it's still left lateralized or right lateralized, and you can see there's two different opinions in these two papers mentioned. And the electrical stimulation of the ILAF and the ansonant fasciculus induce anomias, and which is considered as rooted in the dissociation between the visual image and semantics, picture-based, and a word to be retrieved. And also the stimulation of ILAF causes reading problems. We'll get back to that in the next slide. And damage of primarily the ILAF leads to difficulties in lexical semantic processing, both in comprehension and production. So it's not related to specific language modality. So among these ventral language pathways, the inferior longitudinal fasciculus is the most widely studied. Until recently, its functions were inferred by purely anatomical reasoning. So it connects the temporal pole with the occipital regions, and they both are known to contribute to object recognition, and the symptoms observed when the ILAF was damaged were visual agnosia, prosopagnosia, and alexia, so vision-related problems. So the functions of ILAF were related primarily to the visual processing. And recently, it was shown to be largely involved in semantic and lexical processing. This is why now it is considered as the pathway conveying lexical semantic interface. So there is some evidence supporting that it is involved in semantic processing and lexical semantic processing in particular. So again, thinking about the anatomy, the ILAF provides the link to the anterior temporal lobe, the temporal pole, which is commonly accepted now in neurolinguistic as a transmodal semantic hub. So in patients with semantic dementia and semantic version of the primary progressive aphasia, in which the ILAF is disrupted, we see semantic impairments. And then in healthy population, it has been shown that microstructural properties of both ILAF and the ansonant fasciculus are predictive of successful novel word learning. And also the properties of the ILAF were correlated with the richness of semantic autobiographical memory. These pieces of evidence are taken as supporting the semantic function of the ILF, and the lexical retrieval function of ILF is supported by postsurgical data. That is, after the surgery, the residual tumor infiltration in the left ILF was found to be a strong predictor of stable permanent impairments in naming. And in stroke patients, on the other hand, disruption of the left ILF was predictive of naming impairments for 13 non-unique categories. And for those who are familiar with physiology literature, this is exactly those non-unique category deficits when a patient cannot name animals or fruits or some other entities from some other very specific semantic category. So this is related to the ILF damage nowadays. The answer fasciculus is the least understood language pathway for the moment. The Neurosurgery Society is confident that they can safely remove the answer fasciculus and it won't cause any behavioral consequences to a patient. But neurolinguists found out that its removal causes the impairment of naming of famous faces and objects. And this is exactly why famous faces naming is a very sensitive task for intraoperative mapping of the unsound fasciculus. So we basically present pictures, photos of famous people and ask to name them. But since the unsound fasciculus is intimately anatomically related to the limbic system, it is not clear whether we're talking about language, purely linguistic function, or about emotional component involved in this kind of tasks. So this all brings us to like a new model of language, which some call hodological mode of language, derived from the Greek word hodos, meaning path. So that's the model of language pathways and the critical role of them in the language processing. I would say that these are main postulate of this family of models. And the first of which is that functions of specific pathways should be based in the quality of the transferred and interacting information. A great example of this is the frontal Aslan tract, as I showed you. So it is the tract functionally connecting the language system and the executive control system. And so the function should be derived as providing this kind of interaction between executive control and language. Then most of the tracts have bilateral representation, and it is an open question of what it means for language reorganization due to brain damage. We know that some dorsal tract are more left lateralized, but still most of the associative language-related pathways are not. And which is the most important is a recent finding that in contrast to cortical areas, white matter tracts are characterized by reduced plasticity. That gives this is the basis for the notion of the so-called minimal common brain, which includes white matter tracts as the core anatomical system supporting language, which can change a little bit and make the cortical representations of language shift But if these core elements, white matter tracts, are damaged, then the entire system, language system, is ruined. This is very important for, in particular, for neurosurgery patients, because as you can see here in green, these are different tumors in 3 different patients. So, and in this picture, the tumor is just sitting on a tract, on the fat here, and doesn't affect it. Here, it shifts the frontal Aslan tract considerably to the motor regions. And here you can see a very huge tumor which shifts all the tracts, but still the tracts are not damaged. So they are shifted, the cortical representations are shifted. So if a neurosurgeon, in this case, if a neurosurgeon damages a tract, then the language is considerably affected. And in the same, following the same philosophy for intraoperative language mapping and white matter tract mapping, where and our colleagues suggesting different linguistic tasks to map these different tracts and to tap into their functions. For example, we see that, as I mentioned already, during the stimulation of the IFOF, we observe semantic paraphasias. During the stimulation of the acute fasciculus, we see phonological paraphasias and repetition errors. These are very different aspects of language. And of course, when you map and you try to tap into the function of the IFOF, repetition might not be the task of your choice. Right. So I refer you to this very important paper summarizing the hodological approach to language. And this is one of the first papers suggesting this approach. When specific linguistic and non-linguistic functions are related to specific white matter tracts, and the notion of the limits of white matter plasticity is discussed. At the end of my talk, I would like to mention very interesting recent findings by some colleagues of us and by us ourselves, which suggest some addition to the hodological model of language. And you can take it as quite strong version for the moment, but I suggest you just think about that. That's about the anatomy, the structure, which might drive the function. There is a paper published basically in September, I think, this year in Brain Communications, where they did transcranial magnetic stimulation in neurosurgical patients with tumors pre-operatively. So that was before any kind of resection. And with TMS, they found language positive sites, and then they overlaid, as we did for our intraoperative study, they overlaid these positive sites with tactography, and their positive sites were sitting exactly on the acute fasciculus, specifically on the anterior part of the lung and the anterior indirect segment, and in the Geschmidt territory. For some reason, in the temporal lobe, they were not very specific. So again, as in our study with the frontal Aslan tract, in every individual patient, the anatomy was variable. The anatomy of the acute fasciculus was variable, but it was exactly what drives, it is exactly what drives the cortical representation of language, which was found with TMS. And some time ago, our group presented our recent data about the dominance of the arcuate fasciculus in people with different degree of handedness. So we found left dominance of the arcuate fasciculus in 94% of our 50 participants. And we also did fMRI localizer in these people with the sentence completion task, and we did tractography reconstructions. And there was no association found between the left lateralization of the arcuate fasciculus, which was very strong in the entire cohort, and their handedness, nor their functional lateralization for language. As you can see here, the functional, the representation of language was very variable in this cohort, but it didn't correlate at all with the strong, with the lateralization index of the arcuate fasciculus. But at the same time, of course, it is not just a coincidence that it is approximately the same percentage known in respect of aphasia occurrences. So about 95% of population, when a specific person gets a stroke, become aphasic if the stroke occurs in the left hemisphere. So for us, it means that fMRI maps we get, even with very exquisite linguistic tasks, are not sensitive to the language representation in the brain. And maybe the asymmetry of the white matter tract, the major language white matter tract, the arcuate fasciculus, is what is the most informative about individual language representation and lateralization. I would like to thank the audience and my entire lab. So the work I presented from my lab today was done by many of us. That's not only me. And of course, I would like to acknowledge our funding. Thank you very much.
Right. Thank you very much, Olga. This is a fascinating and such a comprehensive overview.
I can't hear you well, Yuri.
Really nice. You can start by asking. Just a second. Now, did you not hear me at all?
Yeah, it's better now.
Now it is better, but it used to be pretty bad. Maybe you can.
Right.
Turn
I started by thanking you for a comprehensive and fascinating overview of different data. That's really great. I'm really thankful for this. Maybe I could start with a basic question. Like there was at the time of the original Catani and others' work some 15 years ago, there was a lot of talk about differences between male and female brains in terms of arcuate laterality and cross-hemispheric connectivity. I think this was sort of put into this was question since. What do you know about that, or has there been any more research?
I know that further studies made with hundreds of participants did not confirm that.
Right. So basically, this was a false finding. Right. Okay. There is a question from Anna. Anna, please go ahead. Anna Krabas.
Thank you so much for this very interesting overview. I have a couple of questions. Maybe I can ask one first and then another.
Okay, go ahead.
So the first question concerns the arcuate fasciculus data. So usually we talk about arcuate fasciculus as connecting and transferring information from the temporal lobe to the frontal areas. But the data on that you showed on focal stimulation of the arcuate fasciculus and its potential involvement in well, the consequences of like the damage to the arcuate fasciculus with the conduction aphasia suggest that there is not only some like transfer from the temporal lobes to the frontal lobes, but there could be some bidirectional flow of information, because in order to repeat a word, for example, for somebody with a conduction aphasia, you have to not only rely on the feed-forward mechanisms, but also on the feedback mechanisms, right? You have to keep the target, the sensory target in mind that you're trying to repeat, so try to emulate it, right? So that requires some like feedback processing. So like, I don't know data on that. Do you have anything like, is it like, does the flow only proceed in one direction from temporal to frontal lobe with terminations in the frontal lobe, or is it possible for the bidirectional transfer of information?
I believe that, and I guess most of the researchers working in this field believe that it's bidirectional. Maybe to be on the safe side, because we cannot tell, we cannot be sure, or because most of the processes in the brain are bidirectional, multidirectional. And of course, these large pathways include axons going in both directions, right? So it can, I don't believe that's unidirectional. But on the other hand, I'm not aware of an intraoperative study supporting one view or the other. And I can imagine that it could be very difficult to design one. Right.
Yeah, and actually, so my second question relates to that. If I can ask it later if other people want to go ahead.
Just go ahead.
So, I mean, the fasciculi are kind of long, right? And we usually talk about disrupting a function of the fasciculus. Like we know that, for example, simulating the arcuate fasciculus leads to dysarthric articulatory errors. And we also don't know much about how direct electric stimulation of the brain works, about how far the signal propagates along the pathway, for example. So like, does it matter then where you disrupt, where you simulate the fasciculus? Does it lead to, do we need more specificity? We're still talking about different fasciculi as fulfilling some functions, but does it also matter along the fasciculus, for example, where you stimulate or what area of the fasciculus you disrupt? Does that lead to different errors? Is there a dissociation along the pathway? Is it legitimate to talk about just like them as serving one function? Maybe if you stimulate closer to the, for example, if you take arcuate fasciculus and stimulate closer to the frontal areas, that will result in speech errors or articulatory errors. However, if you stimulate it or disrupt it closer to the temporal lobe, that's going to lead to different kinds of errors. Or like if you dissimulate it, it disrupts like the whole fasciculus.
Right. So this is exactly the view of people who really work in the field. Of course, what I overviewed today is great simplification. This is basically similar to how Brock and Wernicke described their language model. Of course, every associative white matter tract I mentioned today consists of subcomponents, anatomical subcomponents, connecting different regions within those huge cortical areas. And I would even start with asking how these subcomponents of each tract are related to specific subfunction of the huge function we're discussing.
Right.
Because at different points of the huge associative tract, there could be different components coming to the surface and ready for stimulation. And we know that arcuate fasciculus, at least the contemporary model of the arcuate fasciculus already incorporates different segments. The ILF, actually, there are different proposals for the subcomponents of ILF, which you know that in our lab, for long we considered as a unitary tract. Now people see up to 5 subcomponents in the ILF only. And this about the frontal Aslan tract, we know the proposal by Marco Catani about 3 branches of it to the coming to the premotor, SMA and pre-SMA, conducting very different functions, starting from core linguistic and finishing with very, very motor peripheral.
Okay, that's great. Since I don't do tractography, I was like wondering if people have started to dissociate different regions.
This is very fresh and recent, and this is what we're trying to do.
Well, thank you very much.
Thank you, Anna.
Right. Any other questions, please? Raise your hand or just speak up. If you need more time to make up your questions, I can ask another one about the evolution of the tracts. There has been a lot of discussion of the arcuate fascicle being the most sort of a hallmark of language evolution in a way, right? So it's considerably differs between even our closest ape relatives and us. What about the other key tracts that you listed? What do we know about the evolution? Whether they can be seen as correlating with language function in any way, or are they more conservative?
Yes, this is a developing enterprise. The comparison of human language-related white matter tracts with what primates have, and so it is not even clear about the arcuate fasciculus, not even to go for other tracts, because as in newborns, the like what remains the arcuate fasciculus in primates is not fully myelinated, or is not as myelinated as in us, human adults. So I wouldn't say that we're ready to seriously discuss something other than the arcuate fasciculus for the moment. People try to do such comparisons, but well, I don't think that we can reconstruct. We can reconstruct the previous state of our hodological language model.
Right. Thank you. Anyone else? Been quiet. I have to say this was extremely clear and also novel to large parts of the audience, I suspect. I can see Olga has switched on her camera. Do you have a question? No?
No, just switching on. Just want to say that really can confirm Yuri's words that it was excellent and very clear and very unique.
Thank you very much for inviting me.
Thank you for joining and for finding the time to present despite Saturday, which is not the working day for many people.
Well, I think these days, every day is a bit of a Saturday, right? Since the lockdown started.
Or the other way around.
Every day is like Monday.
Oh, like Monday, exactly. Or whichever one of them. If there are no more questions, I suggest we thank Olga again. Thank you for the brilliant presentation. And I would give the word back to Olga Sherbakova, who is a chair of the organizing committee, for some closing remarks, I suspect.
Exactly. This is time for a short closing ceremony. Well, these 2 days were very rich and very intense and very thought-provoking, and I believe that all the lectures and all the presentations, they will help all of us to stay in a good shape during these self-isolation times when we cannot collaborate properly when we cannot meet in person. And yeah, so thank you very much for being so brave to try this new format and jump right into it, and being flexible to investigate the new tools. And I think it all worked out very well. It was accurate on time. Everything worked smoothly because of your kind cooperation. So thank you once again. It all happened because of all of you. Thank you for trusting us and for staying with us. My special thank you goes, of course, to our so brilliant keynote speakers who made this conference experience so extraordinary. And that was a very, very special time. And I now would like to say a very huge thank you to people who stayed almost invisible all the time, but who actually ran the whole event, the entire conference. Of course, I'm speaking of the members of the organizing committee. I would like to briefly introduce each of them. And if you guys can, please turn the cameras on so that everyone can see your faces. So we'll start with Varvara. I'm not sure whether she has joined us already, but she was the first one to contact all of you by sending the call for abstracts and replying all the emails, maintaining the communication. She also helped a lot at the early stages of sorting the conference abstracts, so she contributed a lot. Thank you very much, Varvara. Then Katerina Blinova helped with the conference program arrangements and rearrangements, and then another rearrangements due to the multiple requests. And this all worked out because of your patience and accuracy. Thank you very much. She also helped us with moderating sessions together with Ekaterina Andriushenko. Where are you? Yes, I can.
Here.
Thank you. Thank you for all the technical support. Alexander Kirsanov is an author of our sexy conference logo, and also he helped us solving numerous technical issues and things that just didn't work. He helped us to make them working eventually. Then Ekaterina Perikova, thank you so much for all the moderation, a lot of technical things, and she also provided just enormous amount of help and supported us in all the administrative issues, all the organizational things. This would definitely not happen without her. Tatiana Isaeva monitored our YouTube streaming and made sure everything was working there. Yuri, thank you very much for inspiring, for just conception of the whole event. That was initially your idea. And thank you for supervising the Laboratory of Behavioral Neurodynamics, which, as probably everyone knows, is standing behind this lineup of annual conferences. So this would definitely not happen without Yuri. So I think I mentioned everyone, right? And just maybe a couple of last remarks. Abstract book will be published in a short time. I think just give us maybe another couple of weeks to finalize the texts and all the technical things and send it to the printing house. We will post it on our website, and as usual, we will send it to all the presenters, and just check your emails. And I think I will dare to announce the NBSL 2021. We are still not sure about the format, whether it's going to be online again, or hopefully we can be back to our normal offline format, touch wood, but who knows. Anyway, I hope that it will definitely happen, and welcome everyone. I hope we will see our loyal members who keep contributing every year, and some new faces, new collaborators, your new students, co-authors. So stay tuned and hope to see you next year. Thank you very much. It all happened just because the community is very, very bright and very cooperative, and just so beautiful. Thank you very much.
Can I jump in with the last sentence, perhaps? That I'd like also to join the thanks to all the keynote speakers, all presenters, and of course the brilliant organizers whom Olga has already mentioned, but she forgot one person, and that's Dr. Olga Sherbakova herself, who has done a tremendous effort pulling and directing most of the weight for organizing this now 5th year running, but this year felt a bit like the first one with new formats and unpredictable circumstances. So thank you very much, Olga, for organizing the whole thing.
Thank you very much.
And with that, I think we could round up, can we?
Yes, I think it's time just to settle down a bit, and we can maybe keep the Zoom conference on for another few minutes just for people to share their experiences and maybe exchange contacts, because on one hand, there will be in the conference abstracts book, but maybe if you want to start communicating right now, we can provide some more space for this. Thank you for the feedback. It was a pleasure hosting you.
So the conference is now closed. Is that
officially
correct?
closed? Yes. So waiting for the NBSL 2021 to start.
Thank you.
Thank you, Kira. Thank you, Svetlana, Anastasia, Daria. Thank you very much. It's a great pleasure to read the chat now.